Estimados asistentes y miembros de la comunidad SEK, estudiantes, familias, docentes, es un placer daros la bienvenida a la tercera edición del Congreso Científico organizado por la Fundación Felipe Segovia, una cita ya consolidada en nuestra institución que representa lo mejor de lo que somos, una comunidad comprometida con el conocimiento, la innovación y el aprendizaje sin fronteras. Dear attendees and members of the SEK community, students, families and teachers, it is a pleasure to welcome you to the third edition of the Scientific Congress organized by the Felipe Segovia Foundation, an event already consolidated in our institution that represents the best of what we are, a community committed to knowledge, innovation and learning without borders. Hoy celebramos no solo los resultados de vuestras investigaciones, sino también el proceso que habéis recorrido con esfuerzo, curiosidad y compromiso. Este congreso es un reflejo del espíritu de nuestra gran comunidad de aprendizaje, un espacio compartido en el que la ciencia se convierte en el lenguaje común. Desde Madrid, Cataluña, Pontevedra, Almería, Dublín, Qatar, Bahrein y Omán, cada uno de vosotros contribuye a una red de conocimiento global que demuestra que aprender, investigar y avanzar son actos colectivos, sin fronteras ni límites. Today, we celebrate not only the results of your research, but also the process you have gone through with effort, curiosity, and commitment. This Congress is our collective acts without borders or limits. En palabras del neurocientífico David Eagleman, el cerebro es una máquina de hacer hipótesis. Cuando no entiende algo, lo imagina. Cuando lo imagina, lo explora. Cuando lo explora, lo descubre. Y eso es precisamente lo que habéis hecho: observar, cuestionar, imaginar, investigar y descubrir. In the words of the scientist David Eagleman, the brain is an hypothesis-making machine. When it doesn't understand something, it imagines it. When it imagines it, it explores it. When it explores it, it discovers it. And that is precisely what you have done: observed, questioned, imagined, investigated, and discovered. Pero tan importante como investigar es compartir. La ciencia solo crece cuando se comunica. Presentar vuestros proyectos ante esta audiencia, argumentar vuestras ideas, responder preguntas y reflexionar en voz alta forma parte del aprendizaje más valioso que podéis llevaros de aquí, el de ser investigadores con pensamiento crítico, con voz propia y con responsabilidad hacia vuestra comunidad. But just as important as investigating is sharing. Science only grows when it is communicated. Presenting your projects to this audience, arguing your ideas, answering questions, and reflecting out loud is part of the most valuable learning you can take away from here. That of being critically thinking researchers with a voice of your own and with responsibility towards your community. Mi agradecimiento más sincero a quienes han hecho posible este encuentro, los profesores que os han guiado, a las familias que os han acompañado y al equipo organizador por su impecable labor y, por supuesto, a vosotros, estudiantes. Gracias por recordarnos, una vez más, que la ciencia no es solo para unos pocos, es una manera de mirar el mundo con valentía y con esperanza. Bienvenidos y enhorabuena por estar aquí. My sincere thanks to those who have made this meeting possible, the teachers who have guided you, the families who have accompanied you, and the organizing team for the impeccable work, and of course, to you, our students. Thank you for reminding us once again that science is not just for a few. It is a way of looking at the world with courage and hope. Welcome and congratulations for being here.
Honorable General Director, Mr. Iván Martínez, Dear Director of the Fundación Felipe Segovia, Mr. Alejandro Díaz Garreta, Dear Directors and Deputy Directors of all SEK schools, dear teachers, dear fellow students, and dear guests participating both live and online. Once we've heard this warm introductory speech given by Mrs. Elvira Chiquero, Director of SEK El Castillo and creator of this initiative, we kindly beg you to let us introduce ourselves. We're Carla Hidalgo and Diego León, students from SEK Ciudad del Campo and SEK El Castillo, respectively. We're more than glad to welcome and host you as presenteers through the third annual edition of the Scientific Congress of the SEK schools worldwide.
3 years have passed since, in this same venue, this challenging initiative took off. as a path to enhance the introduction to all members of our educational community to the intellectual attraction and the immense universe of potential knowledge that scientific investigation may bear and offer for the future of mankind.
Indeed, we can recall, for example, the improvement that life quality and expectancy have experienced into medical investigation during the past century. It was not until 1928 that Dr. Fleming discovered the first antibiotic, penicillin, a giant step towards fighting bacterial infections. From that moment until now, medical investigation has led us to unthinkable progress, even beginning to cure traditionally fatal diseases through genetic engineering. Last year, I had the amazing opportunity to participate in this gargantuan scientific congress, where I presented a project based on DNA extraction from fruits. The experience of conducting hands-on experiments and sharing my findings with others truly sparked my passion for science. I've always been fascinated by how the human body works, and this project further fueled my interest in biology and medicine. My goal is to become a doctor, ideally a surgeon, so I can combine my love for science with my desire to help people. That's why I'm determined to study a science-related degree at university, where I hope to contribute to meaningful innovations and continue developing my scientific curiosity. In this way, I have a strong feeling that these kind of initiatives help to enhance the link between pre-university scientific focus and the development of scientific vocations in university, which will open the promising range of discoveries that only science is able to display.
The truth is, we can all agree that every human being, from the very moment of birth, opening eyes wide to the world for the first time, is an innate learner. And learning always happens through research. Who does not remember one as a kid, touching everything at hand and even trying to taste it, to the worry and sometimes desperation of parents? I myself was very keen on that. I grew up trying to create and replicate things that astounded me. I built a rustic vacuum cleaner replica, a robot resembling Wall-E, and a music instrument out of different materials. This curiosity has been refined through different projects that I have been able to carry in school and to develop at school. Nowadays, my dream is to become an engineer. My teachers and fellow pupils have accompanied me on this exciting trip from simple experience to the yet unknown knowledge. In this way, we as educational community have followed together the advice of our ancient illustrious Spanish philosopher, Seneca, when stating that long is the way of teaching by theories, short and effective by examples.
It is within this path that during the last year, several students from our school community have developed extremely interesting scientific research projects. They're more than willing to share and disseminate later on their findings with everyone participating in this event. Teams from Qatar, Oman, Bahrain, Dublin, Atlántico, Alborán, Cataluña, Ciudad Campo, and El Castillo are already warming up their motors to provide us with interesting presentations. We're very proud of their efforts and results.
This proves how the enhancing of scientific vocations has been one of the basic aims of the educational task of SEK schools since their establishment back in 1892. And as a result, many of the alumni have followed scientific careers where they have been able to put into practice these spirits for the welfare of society. Today, we have the pleasure to introduce you to the opening inspirational talk by one of them, Mr. Miguel Anaya Martin. Mr. Anaya was born in 1988, and after completing pre-university studies at SEK Ciudad Campo School, obtained a degree in physics and at the University Autónoma de Madrid. Was a Maria Sklodowska-Curie researcher and a Leverhulme career researcher at the University of Cambridge. He did his master in science and PhD at the Institute of Materials Science in Sevilla, where he was also a postdoctoral researcher. He has been a Ramón y Cajal Research Fellow in the Department of Condensed Matter at the University of Sevilla and Royal Academy of Engineering Research Fellow in the Departments of Chemical Engineering and Biotechnology and Physics at the University of Cambridge in the UK. From 2023, he leads a team of 10 researchers on physics, chemistry, engineering, and computing at the Semiconductor Materials of Sustainability Lab in the Department of Condensed Matter at the University of Sevilla. He has won several prizes, the last which in 2024 he is the best young experimental physicist of the Spanish Royal Society of Physics and the BBVA Foundation. He has published more than 60 articles in prestigious scientific magazines such as Nature, Nature Energy, Nature, and Nature Nanotechnology. He has several registered patents and has recently co-founded a technological company that deals in high-energy radiation detection for clinical diagnosis.
Mr. Naya's doctoral thesis was groundbreaking. It focused on understanding, explaining, and designing interactions between radiation and matter in devices based on halide perovskites. These discoveries have had important practical effects. They've made it possible to manufacture solar cells and light-emitting diodes with improved performance and versatility. The project in which Miguel Anaya is currently working at allows the use of halide perovskite instead of cadmium in computer tomography for medical diagnosis. Medical images obtained by computer tomography could be made much more accurate by photon counting detectors. However, the materials currently used to manufacture these detectors, based on cadmium, require a purity that is extremely difficult and therefore economically expensive to achieve. Mr. Anaya's project proposes to use an alternative material, halide perovskite, and encapsulate it in a metal organic lattice to considerably reduce production cost and facilitate the scalability of these detectors, thus making them universal in CT imaging.
Therefore, without further delay, we are glad to invite Mr. Miguel Anaya Martín to the stage and give him the floor.
Wow. Thank you very much for the introduction. It was great. Good job. You have researched a lot in the internet to know what I do. Hoy me hace muchísima ilusión estar aquí hablando a todos vosotros, to all the people that is attending the conference on Zoom or on one of these platforms. And I was proposed to speak about challenges and opportunities on research in material science in Europe and abroad. Okay? And I'm going to focus, of course, in what is my research line, which I think addresses one of the most important challenges, if not the most. But before starting, I want to remind everyone what is a teacher, right? A teacher is someone that teaches you. Is with you helping to improve your skills, is the one that tells you when you do something good, and is the one that criticizes you in a constructive way when you do something that is not as good. And I have been checking all the posters. You did a great job, but looking at my conference and my talk, I want you to tell me later, when I finish, what you forgot in most of the cases in your posters, okay? So pay attention what I put in all the slides, in most of the slides, and in some places in the talk, so you can tell me later what you forgot, which are two important things, okay? First thing, why am I here? Am I here because I was a student in SEK Campo? And am I here because I met Don Juan? Probably, I don't know if you have already met him, or you will suffer, or él es un profesor que es muy exigente, pero es el profesor que más me ha enseñado durante mi época de estudiante de secundaria. And because of Don Juan, I got inspired to study physics. As you said, I studied physics at the Autonomous University of Madrid. And later, very soon, I went to Seville to pursue my PhD studies on photonics for solar cells and LEDs. Later, I went to Cambridge, first as a postdoc in the group of Professor Sam Strangs. Later, with some of these Royal Academy of Engineering research fellowships, I became a principal investigator with my own group there and research fellow in one of these colleges, Darwin College. These colleges in Cambridge and Oxford, the ones that inspired Harry Potter and all these formal dinners and so on. We are the ones that make them in real life. And 2 years ago, I decided to come back to Spain because this was my objective, to do science and to progress here in Spain. And I established This is not the best picture, but I took the other day quickly to be here in the conference. The Semiconductor Materials for Sustainability Laboratory, the SMS Lab, which is a group that focuses on understanding how light and matter interact to design, fabricate, and characterize devices that perform better, optoelectronic devices in particular, that perform better than their counterparts that are nowadays in the market. Okay, and this closes the loop, right? I started in SEK. I got inspired by Don Juan, Seville, Cambridge, come back to Spain. I got this prize that you said, the Spanish Royal Society of Physics, and that's the reason because I am here today. Okay, so this is very important to put things in context. We do research on materials that are used to harvest and use energy in a better way, and this is very related to one of the challenges, if not the most important challenge that we have as human beings nowadays. Okay, and I'm not sure if you have studied this, the Paris Agreement in physics, in natural sciences, in humanities, but this was an agreement in 2015 in which several countries agreed on keeping the average temperatures of the world maximum 2 degrees above the average 100 years ago. Okay? Esto es básicamente combatir contra el calentamiento global. Okay? And one thing that I always say is that this was COP21, the one in which the agreement in Paris was achieved. Now we are in COP29 and still have a lot of issues, right? Countries exiting, joining the agreement, saying that this is true, this is not true, you know, all these things. But what is undeniable, and scientists can prove in all the ways you want, is that this climate change, this global warming, is produced in most important percentage by the emission of CO2, or gases that produce the greenhouse effect, okay? And this greenhouse effect, or the CO2, is emitted mainly because of the combustion of fossil fuels, okay? That are important, or are essential, to give us the energy that we need to function as a society, okay? So we need to decrease, or mitigate, or minimize the use of these fossil fuels because of this reason. If you don't like this argument, because there are a lot of political thinkings, different ones, the other reason is that these fossil fuels are finite. Okay, they are finite. We will run out of them in some decades. Let's put it like this. Okay, and these spheres that I'm saying. These spheres that I am putting here are, let's say, they represent the total amount of these fossil fuels that we have in the Earth, okay? Second thing is that this, if you don't like these two arguments, is that they also depend a lot, or the prices depend a lot on geopolitical issues. So better to not depend on them, because if one day there is a war far away from here, we will have a consequence in what we pay for energy. So why don't we use other alternatives? And the one that my group is investigating more is the use of the sun, no? The power the sun gives to us, which is represented by this sphere that doesn't enter in the slide. And you can see that is enormous in comparison with the total amount of fossil fuels that we have that are present on the Earth. Okay, and this is just in 1 year. This is the energy provided by the sun in yellow, only in 1 year. And that tiny point that I'm not sure if you can see it, that says 2 terawatts, is what we need in 1 year. So why not? Seems like a reasonable way of obtaining energy. And importantly, we live in Spain. There are people there from Bahrain and some other countries that receive a lot of light from the sun. We receive an enormous amount of energy from the sun every year, and it sounds even more reasonable to be leaders on photovoltaic or solar energy production in these countries, right? 2 technologies to harvest energy from the sun. One is this like Sauron Eye. I'm not sure if you are very young to know about the Lord of the Rings, but Sauron's Eye towers. This is the solar thermal energy production, okay? Thousands of mirrors that focus the light from the sun to a tower that has an oil and will boil and get very, very, very hot and will release the energy to move an engine later, okay? This is very good because it solves one of the problems of PV or photovoltaic that I will explain in a minute. Produce energy instantaneously, so when we don't have sun in the night, you don't have energy, right? This was one of the problems that we had some weeks ago because we were producing more energy than we should at some point by PV. These thermal energy plants, they can keep the energy. They are like solar batteries, okay? So you can use the energy later in the night by when the gas is still evaporating and moving the turbines, okay, the engines. In contrast, the problem of these big plants is that they are very big. They need a lot of, let's say, funding to be constructed. You cannot move them, of course, easily. So the access to these plants is not the best. And the alternative is to use these solar photovoltaic panels, which function as you can see here. Basically, what we have is a photon that comes to the solar cell. Let's activate it again. It's absorbed by the active material, produces electrons and holes that are separated, and this gives a current, okay? Voltage and current, that gives power. Instantaneously, so you need a battery if you want to use it in the night, but still very economically, you can make them very, very lightweight. You can transport them and provide energy to the more than 1.2 billion people in the world that have not access to the grid, okay? There are more than 1,000 million people that cannot have access to the normal electricity systems. So if you can give them solar panels, which don't need to be connected to the grid, they can, I don't know, like use their water drinkable or to function, I don't know, medical systems in hospitals, okay? Important thing is that in the last decades, we have been relying on silicon, a technology that has been developed for everything, for all your mobile phones, electronics, etc. This has been very useful. You have solar panels probably in all of your houses or even in the school. I don't know if the school is runs a little bit of the energy by PV. But importantly, the thing is that this has been possible because we can produce more solar panels than what all the projections in the history have told us. Okay, so we always project we are going to be able to produce, I don't know, 100,000 solar panels per year, but we always surpass that projections we have, and this is due to the fact that we have very optimized fabrication protocols, and also we have decreased more than 100 times since 1980 the price of the energy that we produce by these solar panels. But still, and this is because I am here, this silicon needs very energy-intensive processes, so it's okay. It's a, let's say, green, renewable energy, but to produce those silicon panels, you need to purify silicon, make a very crystalline silicon. This requires very high pressures, very high temperatures. This is very high energy intensive. They are not very modular. They are not very versatile because you need all this temperature, and you cannot make them flexible, and so on. And there have been decades of investigation to find alternatives, okay? And it was until 2009 when these halide perovskites erupted in the field, okay? These halide perovskites, just to give you a little bit of context, took just 10 years to reach the efficiencies, and you see the efficiencies in red for halide perovskites and in blue for silicon. They took only 10 years to reach the efficiencies of silicon. That took more than 40 years to reach the 26.6% that you see there, okay? And we did this with a technology that is very cost-effective, so we can produce them very easily, in every lab, from precursors that we can synthesize in every lab in the world, so we don't rely on any silicon that one has to extract from places far away from here. And to give you a little bit of context what the halide perovskite is, or they receive their name because of the crystal structure that they have, okay? It's a little bit with, probably you are studying it in high school, sodium chloride, sal, la sal de casa. All salts received their name because of the crystal structure of sodium chloride, okay? In the same way, all crystalline structures or all materials that have this crystalline structure that is comprised of octahedra in that shape, they receive the name of perovskites. There are many perovskites in the world, okay? Oxide perovskites. There are ferroelectrics, materials for magnetic stuff. We study the ones that are particularly particular because they have halides, so elements like bromine, iodine, and chloride in the vertices of each octahedra. Okay, the red circle in the octahedra is a halide, and these are halide perovskites. Okay, as I said before, they are abundant, they are easy to process, but all this versatility and low-cost fabrication processes wouldn't be nothing if their properties are not the best, right? And these materials absorb light very efficiently. They can produce electrons and holes very, very, very efficiently, and you can extract them almost perfectly. And this makes them very interesting, not only for solar cells, and you will see later, for LEDs or even high-energy radiation detectors, okay? And just to give you an idea, very visual, of why, like, something that you can remember quickly in 2 years, or when one of you wins the prize of the Royal Society of Physics in Spain, can remember this, is that we just need 0.8 microns of perovskite to absorb all the light, okay? Whereas with silicon, you need more than 100 more times, more than 100 more times of thicknesses, okay? And this is compared with the thickness of a human hair, which is 100 microns, and a red blood cell. Esto es un glóbulo rojo, which is 7 microns in size. You see the perovskite is 10 times smaller than a red blood cell. So quite efficient, right? And because we can process them at low temperature, we don't need anymore them to be rigid. We can process them in roll-to-roll because we can deposit them on plastics. We can make very efficient processes, print them like in an inkjet printing machine, and producing them in a massive way, okay? And you can tell me, okay, Miguel, you already presented something that in 10 years have achieved the maximum efficiency they can have, already competing directly with silicon. What's next? Why are you here? Why are you getting the salary that you are getting as a professor in the university? So we as scientists, we always think what's going to be next, okay? What can be next in solar panels? That they can be integrated in buildings, okay? And to be integrated in buildings, you don't want to integrate something that is black. That's not very aesthetically interesting, right? You want it to be colorful, or at least that you can tune the color to make it in the way that you want, okay? And this is something that I did during my PhD. We integrated what is called a photonic crystal, which is this multi-layer. I cannot point with the pointer, but you can see these purple and orange spheres that are periodically stacked in that schematic. This is a photonic crystal, okay? And this photonic crystal provides the solar cell with colors on demand. We just change the thickness or the materials that constitute that photonic crystal, and we can select the color that we want for the solar cell without decreasing the efficiency of the panel. Okay, this is very important. If your panel is 20% efficient, you don't want to make it colorful and lose efficiency, right? Because the most important thing is to receive energy. We managed to do that, and that gave rise to the different patents, and some companies have been interested on this. And you can tell me, this is just aesthetics, right? No, it's not only aesthetic, it's very related to economics, because now if you imagine that you use buildings, the ceilings of your cars that are colorful, you don't need to buy fields far away from cities, that you need to buy, construct the solar panels, make the supports, maintain them, and what is even more important, transport the energy from there, from far away from the city, to your building, okay? With this, we take advantage of something that is already constructed, easy to clean because you are there, you clean your windows, so you can clean your solar panel, and you produce the energy where you are going to use it, okay? So it's very economically beneficial. Other stuff that we do, the concept of tandem solar cell. If instead of using just silicon or just perovskite, now we print perovskite on top of silicon, and perovskite takes care of the high energy photons, the ones that are represented in blue there on the left. Silicon takes care of the low energy photons in red. We can increase the efficiency from 26% to more than 34%. Okay, it's already proven, it's already constructed, it's something that companies are doing already. Okay, and we were one of the first groups in the world that proposed this concept. Okay, and the tandem concept is the same way that you cycle by yourself. You need to employ some energy. If you are two in the same bike, you decrease the energy not by half, but by an important percentage, right? Actually, this concept was so well received in the field that we managed to convince the journal, the scientific journal, to put our concept in the cover. Okay, and here on the right-hand side of the slide, you have the cover that I designed. We designed, and you can see that we managed to put the skyline of, in this case, Seville, because I was studying in Seville, in the journal, in the cover of a very reputed UK journal. More things you were mentioning before, not only solar cells. We need not only to harvest energy in a very efficient and cheap way, we need to use it in a very efficient way. And one of the main reasons, or one of the main factors that make us consuming more and more energy is light. Everyone uses light for everything. Displays, illuminating your life, Christmas, right? Human beings like light, to be illuminated, okay? It's something that makes us comfortable since all the old times with fire, right? Something that is very important to know is that, and if you study physics, and in particular optoelectronics, you will learn, is that a good solar cell is a good LED, okay? I'm not going to enter on the reasons behind it. If you want to ask me in the coffee break, I'm very happy to try to explain. But basically, in the same way that we can absorb a photon and give rise to current, if we inject current, electrons and holes, they can recombine reactively, emitting a photon from the device, okay? And this is an LED. This is also something that we do in the group. These are LEDs or the type of LEDs that we produce in the group, and the reason behind using them is because we produce more light per watt than 5 minutes, perfect, than in any other technology, okay? So this basically means that we need to spend less energy or less power, so money, to give you the same brightness than with other, like, I don't know, lamps that you can think of the past, no? Bulbs, etc. Because of the way in which they work and because they are so efficient, they don't heat up. So their lifetimes, the operational lifetime, how long they last is very long, okay? They last for years, even though you think, okay, now the LED is broken. Well, you don't want to know how it was a couple of decades ago with traditional bulbs, okay? And third is that they are very small, or we can miniaturize them very easily, okay? So we can produce screens that have more and more resolution, okay? And the true black, have you seen that advertisement in TV? The true black, OLED, okay? Organic LEDs. These are perovskite LEDs, very similar to organic LEDs, but even more efficient and with better color purity, okay? So this is something that will be next in the I hope, in the market, okay? And you can see here some examples of blue, green, and red LEDs that we can produce. We produced in Cambridge, and now we are trying to make them in Spain. Blue, green, and red gives you all the palette of colors, okay? And something very important, in the same way that we were able to produce flexible photovoltaic panels, now we can produce flexible displays. And probably you have already seen solutions in the market or mobile phones that you can roll and maybe roll on your hand and so on, okay? And third topic, because I don't want to extend that much my talk, is high energy radiation detectors, something again that you mentioned. We have co-founded that company, I will show you in a minute. In the same way that these materials are very good in absorbing photons for solar cells or photodetectors, the optical photons, so the photons that the sun provides us with. These materials are very efficient in absorbing other type of photons, photons that are more energetic, okay? X-rays or gamma rays, okay? And you can tell me, why are these systems, or why do we want to absorb X-rays? Your colleagues all mentioned, so you should know. Because, as you know, X-rays have facilitated the CT scans, radiographies, and so on, which have been crucial in the last century to diagnose and monitor diseases, right? And this is becoming more and more and more important. Why? Because our population is aging and is increasing. So we are more and older, okay? So in particular, because we are older, we need to screen people more and more and more frequently to be able to detect diseases as soon as they happen, okay, or as soon as they appear. Because treating a patient earlier can save his life or her life, okay? But second, treatments that are at early stage are way more cheaper than treatments that are at later stages, okay? Especially in cancer. And this is the motivation or the business case, if you want to call it like that, of a company that with other 4 colleagues I co-founded in Cambridge, and now we are growing. So if you want to become a physicist and in 4 or 5 years you want to work in the company, we have open positions, and I hope in this decade we will have more and more and we will grow, okay? And this is a message that I wanted to almost finish with. I am a physicist, but we always think in the application, okay? And it's very important for me to have that way of thinking, because I'm not a physicist because I just want to investigate something that is curious to me. I'm a physicist because I want to have impact, okay? So I want to investigate something that can help society and people to use energy or to save their lives, okay? So we work a lot in the group, as you said. We are physicists, chemists, computational scientists, and engineers. So we work a lot in the group to translate pure research, okay, into innovation, so into something that is industrially interesting, okay? And very quickly, I promised you to tell you something about my path at the early stage, because I think this is what you need to choose in 1 or 2 years. I moved around a lot, okay? Like some tricks here or tips for your career. Don't stay in the same place always, okay? I studied in the Autonomous University of Madrid, but in my 4th year of the bachelor, I went to Seville, and in my 5th year, you don't have 5 years anymore, but you can do it in earlier. In my 5th year, I went to the Free University of Berlin, so I could take information about how things are made in other places, okay? How things are done in other places. You need to be honest with yourself. You need to be honest in what you like, what you don't like, what you are good at, and what you need to improve. Don't be in the comfort zone always. You need to change. I'm not very good in English, but I don't care. I explain. I can speak in English. I can give you provide you information in English, and try to improve things with time, okay? Learn English. I don't think this is the problem of most of you, but this is the research language, okay? The language for almost everything. Computation. Learn how to code. No matter if you do, I don't know, clinical studies, biology, chemistry, physics, humanities. Code. Learn how to code. Now it's very easy. With ChatGPT can help you a lot. Python, okay? This is what I just said. Move around, don't stay in the same place, and always have a plan, okay? Do you want to be in academy? So go for it. Industry, good as well. In Spain, abroad, you want to be abroad and then come back, always think what you want, because you will need to apply for scholarships, apply for jobs, ask for help, motivation letters, reference letters. to get what you want, okay? And something very important, the life is, or your life will be about decisions, okay? And you can make wrong decisions, but make sure that your right decisions are the ones that dictate your future, okay? This is very important. I want to thank everyone in the group. These are the people, Victoria, Luisa, Susana, Aaron, Sol, Jaime, Guadalupe, Carmen, all of them are postdocs, postdoctoral researchers and pre-docs, so PhD students, that together with the undergrads are the ones that are hands-on doing science, right? I'm not anymore in the lab. I am always planning and helping them deciding what to do. So it's very important for me, all of them, because to have all of them in the group, and also the funding, because the funding is the one that allows us to buy equipment and do what we do. And before finishing, I told you, I promised I was going to ask about which 2 things you have forgotten in most of the posters. And this is not just to criticize you, it's so next year you don't forget. Ideas? One is this one. You missed in 90% of the posters the acknowledgement. Okay, I'm sure that you are very good. The guys, the authors of the paper, of the posters, you are great. You do everything, but for sure you have someone to acknowledge, at least the teacher. Okay, and second thing that most of you forgot. Do you see what I put in under every picture or result of my work or works of others? References, okay? You cannot make a poster without any reference. For sure, you have taken information from somewhere. And Wikipedia is not a reference, ChatGPT is not a reference. A reference is a scientific paper, okay? And with this, I just have to thank you for your attention, and later we will speak. Questions now or later? Do you have any question, or we just wait for the round table? Later. Perfect.
As Francisco Quevedo commented, thankfulness is the main part of a good human being. Thank you very much, Dr. Anaya, for your enlightening and inspiring words.
And now, after this initial intellectual appetizer, we will move on to the next part of the Scientific Congress. The student teams from the participating schools will present the outcomes of their respective scientific research projects. But before starting, we beg the audience for some kind of interaction in the form of feedback on the different presentations. For those attending online, we've offered you a link. Whereas for those who are physically here with us, there's a QR code through which you can access questions about the different projects that you're about to hear today. Also, you will find a final question about who you think that best communicated the findings. We can also give recognition to the best listeners in the room. We must insist on the importance of your active feedback for the success of this Congress. Therefore, we would truly appreciate if you were able to answer the first 2 questions, which are the following. From which school are you joining, and what is your favorite area of science? Thank you in advance. We'll leave you now 2 minutes so that you can do this. And once finished, the first round of interventions before the breakfast break will be featured in this order by the teams from Qatar, Bahrain, Oman, Dublin, and Atlántico SEK schools.
As well, it is known that developments in science do not only lay on research as such. Dissemination and communication of findings play an important active role for a new finding to be accepted by the scientific community, and in the end have a positive impact on daily life. This is a fundamental part of the SEK profile of learning. Communication is a two-way motorway. The scientists have to explain their findings so that colleagues and the public understand them, and the degree in which recipients of the information can digest new scientific breakthroughs is essential for science to become useful in practice.
And now we give the floor to the first in row, the Qatar team. We therefore call Asel Akasha, Noor Jukobi, Laila Bader, and Amina Said Aldien, who are going to present a project on health literacy and type 1 diabetes. Good luck.
Hi, my name is Noor.
And my name is Amina.
Today we're going to be presenting our project on health literacy, with parents based on the treatment of diabetes.
So to begin, we'd like to thank you for this opportunity, and we're presenting SEK in Qatar.
You're not sharing.
Then what? Then what?
Our presentation is on health literacy in relation to diabetes. And we're fortunate enough to present this in Cornell University located in Doha, Qatar. And we had two other partners who participated in this as well, but unfortunately they could not make it today. So it's only me and Noor representing our project. To begin, as many of you might know, we've realized and recognized through our research that there has been a large increase in diabetes, and specifically in children and in type 1 as well. And there's a lot of relations that we can relate to about why this may occur or why this pattern has occurred, including diet, lifestyle, and also genetics. But we want to focus specifically on type 1 diabetes, since it's not from specifically diet and chosen circumstances, but it's hereditary, or it's from when you're born. So we want to see how the children's life is affected, and their lifestyle and their life quality when their children are educated or not. So the research question we have established is our guiding research question is: how does a parent's health literacy affect their child's age from 5 to 12 that has type 1 diabetes blood sugar levels, which directly also affects their life health quality?
So for our method for data collection and research processes, we first looked at examples of S-TOFLA tests, which relates to diabetes in general online, just to gain an idea of the format and types of questions typically asked to create our own version of the S-TOFLA test. So when creating this test, we collected research questions that contain questions about demographics and general questions about type 1 diabetes in children later on, which was also checked by supervisors. And after editing for our third step, after editing the form based on our feedback, we translated the final draft in English to Arabic and received confirmation for the accuracy of translation from people fluent in Arabic. And we also, for our final step, we completed a final review of both the tests in English and Arabic and sent them to parents and public. So for our results in graph 1, we looked at the years known of the parents known of diagnosis and their education level, and compared their overall average score from the results of the health literacy test. We have 4 variables representing the different durations of knowledge about the parents' knowledge about their child diabetes type 1 diagnosis and their corresponding health literacy levels. Overall, the results didn't show a strong link between the diagnosis duration and health literacy, except for the parents who knew about their child's diagnosis for more than 11 years had the highest health literacy levels. The results for graph 2, we have 2 variables, the parents with a high school diploma and parents with a bachelor's degree, correlating with their health literacy scores. As you can see, the parents with a high school diploma showed a subordinate of an average of score of 13 out of 19, representing a less stable blood sugar in their children. And the parents with a bachelor degree showed significantly higher health literacy, with an average score of 15 out of 19, resulting in a healthier child. This proves that the better education a parent has, the better their health literacy is, resulting in a child which has more stable blood sugar, hence the health of their child. In graph 3, we have a pie chart which lists the 3 variables representing the blood sugar levels and their parents' health literacy. The first group scored 31% on their health literacy test. So it showed that their children had an unhealthy blood sugar, which was sugar levels higher than the recommended range. In the second group, it scored 68%, showing moderate health literacy, but their child's blood sugar was still unhealthy, being less than the recommended range. And in the third group, had the highest score of health literacy, 84%, representing their strong health literacy knowledge, and they also had healthier children with the blood sugar within the recommended range.
In conclusion, we established understanding that the parental health literacy does affect and can be linked to the health of children with type 1 diabetes. And we can establish this from looking at the graphs and the years, for example, the years of the diagnosis, the parents' education level and their diplomas, and their overall average score from the result of the health literacy test. This analysis showcases that higher parental health literacy is linked to maintaining a child's healthy blood sugar within their recommended range, and this emphasizes the importance of managing their child's diabetes and overall health.
For future research, since Qatar is a multicultural community, we could target specific audiences regarding their ethnic groups. We can compare their ethnic groups to provide a good basis for deciding which groups to focus on to provide more education for their health literacy to result in healthier children. In our results, there was also a pattern of lower results between younger parents rather than older parents. So for our next data collection, we could focus on targeting younger parents, providing them more education about health, about their children's diabetes type 1, and promoting a better health literacy to gain a group. Thank you so much for listening.
Thank you.
What a fascinating presentation. It really gives us a lot to think about. Next in row are Eman Omer Nakwi, Tamim Hadi Abu Rashed, Farah El Said, who are going to talk us about their aflatoxin studies.
The study we'll be presenting originated in our participation in the Well Cornell Research competition, in which we reached the finalist spot, but unfortunately did not win the competition. We made it to top 16 out of 100 schools. So thanks to Iman, Farah, and I for spending multiple months on the study, conducting great research, and also taking the opportunity to spending time to work on a study. It took many hours and contribution with multiple teachers and multiple parents. So in this study, Farah, Iman, and I focused on creating an environment for plants and legumes devoid of aflatoxin. Now, what is aflatoxin? Aflatoxin is a mycotoxin released by fungi. This aflatoxin is a mycotoxin that is a carcinogen that causes liver cancer, specifically hepatocellular carcinoma. Now, I'd like to ask a question. Out of these two pictures, which picture, pistachio or peanuts, have mycotoxin I'm talking about, aflatoxin? Pick your choice, I'll say the answer now. If you pick the left photo, you'd be wrong, and if you pick the right photo, you'd be wrong. The actual answer is both of them are prevalent in aflatoxin, and that's the big issue. Aflatoxin is unnoticeable. It is the human eye is unable to see aflatoxin and can only be seen through UV lights, but not everyone walks around carrying UV lights. That's the main issue. Now, not only that, but it's prevalent in milk, dairy, legumes, vegetables, as it can be transmitted through animal graze. And that's one of the biggest issues in Qatar and the Middle East. And not only in the Middle East, all around the world. Dairy levels, prevalence of aflatoxin dairy levels are quite low, which may seem like a good thing, but consistent digestion of low levels of aflatoxin will result in an 80% increase in likelihood of liver cancer. Additionally, aflatoxin thrives in humid and warm temperature. And with climate change, more countries are becoming more humid and more warm, resulting in even greater levels of aflatoxin around the world. And many of us do digest nuts, dairy, grains, especially dairy products, as many people in the Middle East region consume dairy products on a daily basis. Milk, cheese, with cheese and butter having the highest levels of aflatoxin compared to the other dairy products such as milk.
Okay, so for our initial data analysis techniques, we aim to understand aflatoxin generally from its global and health impacts. So we conducted extensive reviews of different academic sources from local and international websites. So we conducted this literature review by focusing on different factors and variables, including the prevalence in different types of climates, the health risks, as we mentioned, the liver cancer, sources of contamination, detection methods, and research trends, as well as mitigation strategies that we can use for our final conclusion. So we initially interviewed an expert in the field, and we received a lot of insight from him within the biocontrol strategy and method. So we learned more about the toxic fungi and its mycotoxins, and we focused on methods to control aflatoxin in certain environments, as well as focusing in our environment in Qatar, and the challenges in how we can prevent aflatoxin. So we learned about new prevention techniques and methods, such as the use of pesticides, bacterial yeast, and even camel gut bacteria. So we sent out a public survey to students, teachers, people around Qatar, and our objective was to assess the public knowledge of aflatoxin and its related risks. So the survey was conducted to gather data on people's knowledge of aflatoxin dangers, their dietary habits related to aflatoxin exposure, so eating dairies and legumes as well as grains. And the survey, we collected over 200 responses, and the results helped us provide new information for our overall project into the public, the general public, their understanding and daily life.
Now, in the first data graph, we analyzed the prevalence of aflatoxin in different temperatures and moisture levels. As you can see, in humidity levels lower than 5%, aflatoxin is no longer prevalent, and temperatures lower than 20 degrees Celsius, aflatoxin is at much lower levels, meaning that if we were to genetically modify a plant or to identify plants that can survive in harsh temperatures, we can create an environment where aflatoxin is no longer prevalent. The next one, we analyze the prevalence of aflatoxin in dairy products. 77.8% of dairy products contain aflatoxin on average, and this is high risk due to diet and contamination from animal feed. Also, cheese and milk having the highest prevalence, with 85% of these products being prevalent in aflatoxin. This final graph, we analyze the prevalence of aflatoxin in different water activity levels. Water activity is essentially the purity of water, one being most pure and zero, essentially meaning it's not water at all. Aflatoxin appears at water activity levels of 0.94 or higher, while legumes, in contrast, can grow in water activity levels as low as 0.86. This data suggests that humidity and water activity control are possible solutions to reduce contamination of aflatoxin.
Now, our study concludes a solution to conquering aflatoxin. This is to create a greenhouse concept. Our greenhouse concept will integrate water controlled activity, temperature, and humidity controlled. The temperature will be controlled through cooling fans and electric heaters in order to achieve desired temperature, and humidity will be controlled by humidifiers, which will lower the humidity rate in the greenhouse. Now, this is vital because, as you know, aflatoxin is grown in humid environments. So if we control the environment of the greenhouse, we can prevent the produce being infected with aflatoxin. Now, these electric heaters and cooling fans will be sustainably powered through solar panels, which will also reduce greenhouse emissions. Now, after all this effort being put in to reduce aflatoxin in the produce in the growing stage in the greenhouse, we want to make sure that when transporting the produce, it's not subjected to aflatoxin either. Therefore, in trucks and the transportation process of produce, cooling fans, heaters, and electric fans will also be put into the transportation. Now, the health impact of this is that it lowers the HCC rates and as well as develops new farming techniques which can promote a healthier and longer life expectancy. Now, for future research, scientists can discover new ways to make the humidity and the temperature control more sustainable
as well as think of more ways to there's a new study that scientists are conducting to genetically modify the produce to see whether we can reduce aflatoxin rates from an earlier stage. So our future research can be to see new ways to improve our greenhouse concept, as well as biotechnology to furthermore understand how aflatoxin is grown.
Thank you.
Thank you.
Your passion for this topic really shines through. Well, are you feeling a bit thirsty? Our next peers from Bahrain, Mia Yusuf and Mona Saik Saleh, are going to explain us how the different types of acidic drinks affect eggshells.
Okay, hi, good afternoon, everyone. I'm Mona.
And I'm Maya.
And today we'll be discussing the effect of acidic liquids on eggshells as a model for tooth enamel. Okay, so our research question was, how do different liquids such as Coca-Cola, coffee, orange juice, Gatorade, and water affect teeth using eggshells as a model, measured in grams using a scale? Our main focus for this investigation was change in properties such as weight, texture, and color. We chose eggshells because eggshells are very similar to how our tooth enamel is created. Eggshells are made of calcium carbonate, similar to how tooth enamel is created, which is made of calcium phosphate. And eggshells are very easy to obtain and safe to use, and they represent how acidity impacts dental health. We chose these drinks that we mentioned earlier because, first off, Coca-Cola has a very low acidic level, which is 2.5 the pH, and it contains sugars and dyes. Orange juice is 3.5 the pH. Gatorade is very acidic and contains dyes. Coffee is less acidic, but it is known to cause discoloration due to tannins. Water was used as a control variable.
So our objective for this investigation was to investigate how liquids with high acidity, such as Coca-Cola, orange juice, coffee, and Gatorade, affect the weight, the texture, and the color of the eggshells, using them as a model for tooth enamel in order to understand the effect of these common drinks on teeth. Liquid with higher acidity, such as orange juice, Gatorade, and Coca-Cola, will cause greater weight loss, texture damage, and discoloration in eggshells compared to the ones that are less acidic, like water. This is because acidic substances react with calcium carbonate.
Okay, so the steps we took, starting off with preparing the eggshells, we cracked them and we washed them to make sure that there wasn't any residue on them. After that, we weighed them to make sure that they were all in the same weight range. We prepared the drinks, measured 200 ml of each drinks and poured it into separate cups. We soaked the eggshells using tongs for a specific amount of time, which was 15 minutes. We started the timers, we observed the eggshells, and after soaking the eggshells for the duration, we visually observed for any texture or discoloration, and then used the scale to compare the weights before and after. After that, we repeated the process 5 times for each drink.
So after doing the procedure, we put all of our data in a table and we did all the calculations. Coca-Cola, orange juice, coffee, and Gatorade, all the acidic drinks showed a weight loss, while water showed a weight gain due to absorption.
This is, you can't see the slides. So you can't see the slides.
So our graph visually compares the average weight change of the eggshells after being soaked in the different liquids. As shown in the graph, the acidic liquids showed a weight loss compared to the ones that showed weight gain, which was water. For our data interpretation, the data showed that acidic drinks like Coca-Cola and orange juice cause the most weight loss and texture erosion to the eggshells. This means they have a stronger effect of eroding the shell. Coffee and Gatorade showed weight loss and a lot of discoloration, but not as much as the other two. Water was the only liquid that showed weight gain due to absorption. Overall, the more acidic the drink, the more damage occurred to the eggshells. In conclusion, the results of this experiment supported the hypothesis that acidic drinks would damage the eggshells. The Coca-Cola, orange juice, and Gatorade caused the most weight loss and texture erosion out of the 5. Discoloration appeared in the Coca-Cola, coffee, and surprisingly in the Gatorade. This showed that acidic drinks do cause damage to the teeth.
Okay, so for our investigation, our evaluation included strengths, weaknesses, and improvements. Our strengths were clear negative correlation found, logical connection between acidity and eggshell changes. Weaknesses included subjective texture or color observation, unequal submersion times. Improvements for next time could be using a color or texture rubric and soaking the eggs one at a time for timing. This is our work cited, and thank you.
What an amazing job! But even more fascinating is the topic of the relationship between age and memory, which will be presented by Ramesh Alahawi and Dabia Asher.
Hi, my name is Lamis Al-Alawi. And my name is Labia, and we will be discussing the effects of age on memory. So our research question was, how does age affect memory, specifically short-term memory? And we hypothesized that there would be a negative correlation between age and short-term memory. So if the age of a person increases, then their memory will decrease. And we predict this negative correlation because aging naturally leads to a decrease in neuronal and cognitive decline. So the scientific reasoning: with age, the brain naturally begins to shrink. This is called atrophy. And this atrophy usually starts around middle age, which is around 30 years old, with this rate increasing more rapidly after age 60. However, this atrophy is not consistent across all parts of the brain, and it tends to be particular to certain parts. The parts that experience the most volume loss include the hippocampus, which is said to play a key role in memory. If we look over here on the left, we can see 2 scans of 2 brains. These brains are identical, with the only difference between them being age. These are 2 healthy individuals. If we look over here, we can see the red highlighted part. This is the hippocampus. This one over here is a 25-year-old brain, and this one over here is a 76-year-old. If we compare the 2 sizes of the hippocampuses, we can see that the 76-year-old hippocampus is slightly smaller than the other one. This is because older adults tend to have smaller hippocampal volumes, leading to poorer cognitive function, including storing and remembering information. So our variables. Our independent variable was the age of the participants, and their ages ranged from 10 years old to 50 years old. The dependent variable was the number of words they remembered, in other words, their memory. And our control variables included the words, the slide order, the viewing time per slide, the testing environment, the recall method, and the gender. All participants were male. So our method, this was our materials, this is our procedure. So what we would do is we would bring the participant into a room, we'd show them a slide with 10 words for 30 seconds. After that, we'd hide the words, and then they would have 30 seconds to write down all the words that they can remember. And this process would be repeated for all 5 slides. After that, we would collect all the papers and then would count the number of the words correctly remembered. And then we'll repeat the same process for each age group. This is our raw data. If you look over here on the graph, you can see that it starts with a rise, peaking at 17 years old with 7.4 words out of 9 remembered. Then there's a decline followed by an even sharper decline, followed by a spike. So the top 3 scores were 7.4 out of 9 words remembered by the 17-year-old, then 7 words remembered by the 14-year-old, then 7.2 by the 50-year-old. This is our process data, and this shows the percent of change or the increase or decrease in words remembered as the age increases. Data interpretation.
Okay, so for the data interpretation, this data indicates an overall negative correlation between age and memory, though it's mixed. So it is shown that memory improves up to age 17, then begins to decline. So on average, memory drops by 30% per decade, excluding anomalies, or 11.28 if the 125% increase in the 40 to 50 age group is excluded. So this unexpected rise could likely be due to individual differences, as a participant we tested was a musician. So the overall trend still shows declining memory with age, especially a sharp drop after age 30. So this supports research linking memory decline to hippocampal shrinkage, which affects episodic memory and processing speed. So for the conclusion, the hypothesis expected memory to decline with age, and the results acquired only partially confirmed this. So teenagers had the highest recall, suggesting that memory may peak during adolescence. However, a 50-year-old participant scored a surprisingly high 80%, indicating that memory does not necessarily decline with age. So individual factors such as health, language, or even experiences, such as being a musician, since the 50-year-old participant we tested was in fact a musician, may impact memory. So research also supports the idea that playing instruments benefits brain function. So overall, the findings show that memory ability varies widely and isn't purely dependent on age. So now for the evaluation, are like some errors we faced were having only one participant per age group and the large age gaps between the age groups and the individual differences, like I said earlier, such as language, education, and all of that stuff, and nervousness or pressure. So how we can improve them, like fix them for next time, could be testing at least 3 participants per age group and choosing more evenly spread age groups and choosing people with similar backgrounds, as well as giving more relaxed instructions and making sure that the participant is 100% comfortable. Thank you so much.
Now, more related to the first project from Bahrain, our peers from Oman, Atlina, Mamoun, Al-Kutub, Al-Jamin, Al-Sbar, Al-Busairi, Amira Al-Isai, Fout Ahmed Jama, and Salma Mohamed Hijazi, hope I haven't mispronounced anybody, are going to state the effect of energy drinks on physical performance.
Hello, so today we're going to be talking about the effects of energy drinks on our physical performance. Our introduction, so we explored the impact of energy drinks on our energy drink consumptions on our energy. And will energy drinks really improve endurance and strength, as in our push-up exercises? And we'll be increasing dosage of energy drinks over 6 consecutive days, and will it lead to improvements in our performance? This investigation was done for educational purposes only, and as energy drinks should not be recommended for kids to drink. This study has been done before by the DAWS Octave 2011 by Redline, where they took 2 control groups. One group did take the energy drink and one group did not. However, our investigation is different, where we're increasing the dosage per day and we're seeing if it will increase our performance. And our hypothesis is if the volume of energy drink consumption over a number of days will increase, and will it improve our endurance and strength, and it will be measured by students and number of push-up per minute.
So here is our 5 volunteers. In our method, we needed to drink energy drinks for 6 days, and every day we increase the dose by 50 milliliter. And we take the energy drinks 5 minutes before doing the push-ups, and we do the push-ups for per 1 minute to see if the energy drink gonna improve our performance or it's gonna stay the same. And we needed to take permissions from our parents before doing this. Our variables, independent variable is the amount of energy drink that we're taking, and the dependent variable, the number of push-ups that we're doing.
Our results consist of our push-up performance. The results show that our push-up performance generally improved as the volume and dosage of drink increases, although there were some fluctuations of performance across some participants due to us all having different fitness levels. In this table, in the second column, you can see our increment of drink volume, how it changed, and the last column shows the mean, shows our average. And here in the graph, you can see the light green line is the mean.
Our findings and analysis. So the first 3 days, they were inconsistent results, but after the 4th day and onwards, the results were being more consistent and were increasing slowly. Potential areas could have included our miscounts in the push-ups, fatigue, influence on day-to-day activities, health variability, etc.
In conclusion, the hypothesis is generally supported. When the dosage of the energy drink is increased every day, it improves the strength of each student who's doing push-ups. How true and reliable are these results? The results suggest a need for more studies. For example, more participants, we could have got more people to do the experiments, better controls, other physiological measurements, and different exercises, for example, swimming or running, higher doses of the energy drinks, and we could have done the activities for a longer duration. Thank you.
Thank you very much for such a thought-provoking speech. The next school presenting is SEK Dublin, where the students Gemin Ma, Sofia Gras-Christie, and Anna Sofin, and Olga Recuero are going to explain us the relationship between the concentration of sugar and the electrical output of a microbial battery.
Hello, I'm Sophia and this is Jimin. It's a pleasure to represent SEK Dublin today. Today, we're going to show you how we create electricity using something unexpected, sugar. Okay. We worked with microbial fuel cells, or MFCs. These are simple systems where bacteria breaks down sugar to release electrons, which generate electricity. For safety reasons, we couldn't use real wastewater in our experiment. So instead, we simulated it by dissolving sugar in water. The sugar acted like the organic waste found in sewage. This project connects the UN Sustainable Development Goals, especially clean water, as MFCs reduce organic waste in water, making it safer to reuse. Clean energy, as MFCs turn waste into electricity, offering a low-cost power source. And climate action, as MFCs help lower greenhouse gas emissions from wastewater treatment.
We changed the sugar level, that's our independent variable. We measured the voltage and the pH 2 times a day for 5 times. Those are our dependent variables. Everything else, like amount of mud and temperature, we kept the same. To test our idea, we made 4 MFCs. Each one had a different amount of sugar inside each jar. We used mud from the garden, added the sugar water, and inserted 2 graphite rods as electrodes.
This diagram shows how glucose is broken down by bacteria at the anode, releasing protons and electrons. The electrons flow through a circuit, creating an electromotive force that powers a light bulb, while at the cathode, oxygen combines with the protons and electrons to form water. Now, for the results. We found that the more sugar we added, the more voltage the MFC produced. The MFC, with 10 grams per liter, reached the highest voltage of 0.3 volts. This tells us when bacteria has more sugar to feed on, they produce more energy.
We also saw the current increase with sugar levels. That means more electrons were flowing.
We also measured pH to track bacterial activity. As bacteria broke down sugar, they released protons. This made the water more acidic, so at higher sugar levels, the pH dropped more, meaning more bacterial action. When we combined the voltage and the current, we calculated power density. This just went from 20 to 225 milliwatts per square meter. That's more than 10 times higher.
This technology has real-world applications. MFCs could help clean sewage water, manage farm waste, and reduce industrial pollution, while also creating electricity. It's a double win: clean water and clean energy.
Our conclusion: sugar works. It boosted all our results: voltage, current, and power. What's interesting is that even at 10 grams per liter, we didn't see the system slow down. In biology, we often expect the point where more sugar stops helping. something described by the Michaelis-Menten model of enzyme kinetics, where reactions eventually level off when enzymes are fully saturated. In simple terms, this means the bacterial enzymes involved in respiration can't process any more glucose. They're working at full capacity, and extra sugar doesn't lead to more energy output. We think future tests with even more sugar could help us find that point and decide if real wastewater can be treated directly or if it needs to be diluted before.
So, how sweet is the current? Very sweet. Thank you for listening. We hope this project show you how bacteria and sugar can help power a more sustainable future.
Thank you.
Thank you.
Moving on, the last group to present before the breakfast break will be SEK Atlántico. Lola Maceras Besada, Candela Otero Freire, and Lucía Villaverde Lorenzo are going to demonstrate the effect of temperature on the oxidation speed of vitamin C.
Audio y vídeo, ¿no?
Ah, no está cambiando tampoco, claro. No, se va. Es que ¿Alguna vez han escuchado la frase tómate rápido el zumo que se va la vitamina? Esta famosa frase podría hacernos pensar que el oxígeno del aire según la reacción que podéis ver en la diapositiva, haciendo que pierda su capacidad antioxidante, que es la que la hace beneficiosa para nuestra salud. Pero, ¿influirá también la temperatura a la que esté almacenada el zumo en la reacción de oxidación de la vitamina? ¿Es más aconsejable almacenar el zumo a altas o a bajas temperaturas para que conserven sus propiedades? El objetivo de esta investigación es dar respuesta a estas cuestiones, siendo por tanto nuestra pregunta de investigación ¿cómo influye la temperatura a la velocidad de oxidación del ácido ascórbico determinada a través de iodometría? Teniendo en cuenta que la velocidad de una reacción es proporcional a la concentración de ácido ascórbico elevado a un exponente denominado orden de reacción, siendo la constante de proporcionalidad la constante cinética K. Si suponemos que la reacción es de primer orden, entonces la velocidad será proporcional a K. Nuestra hipótesis es que se cumple la ecuación de Arrhenius, que, como podéis ver, establece que K, y por tanto la velocidad, aumenta exponencialmente con la temperatura, debido a que habrá mayor fracción de partículas con energía suficiente para que se produzca la reacción.
Para poder determinar la velocidad de oxidación del ácido ascórbico, teníamos que medir su concentración a lo largo del tiempo. Por ello, introducimos 3 vasos con el mismo volumen de zumo en un baño termostatizado a la temperatura deseada. Y cada 40 minutos extraemos una muestra. Añadimos el almidón como indicador y valoramos con la disolución de concentración de yodo perfectamente conocida, siguiendo los pasos que podéis ver en el vídeo. Al añadir el yodo, el ácido ascórbico reacciona hasta que se consume por completo. En ese momento, el yodo quedará en exceso y formará un complejo de color oscuro con el almidón. Ese cambio de color, llamado punto de equivalencia, indica que la reacción ha sido completada.
Con el paso del tiempo, la concentración de ácido ascórbico va a ir disminuyendo al formarse ácido de hidroascorbato, que carece de propiedades antioxidantes. La velocidad de la reacción es el cambio de la concentración del reactivo, en este caso la vitamina C, por unidad de tiempo. En esta reacción de oxidación puede determinarse a través del seguimiento de la concentración de ácido ascórbico con el tiempo, por la estequiometría de esta reacción, que veis en pantalla. Para ello, hemos llevado a cabo una valoración redox, en concreto una yodometría, en la que hicimos reaccionar la vitamina C con yodo, un valorante de concentración perfectamente conocida. Representamos la concentración frente al tiempo para obtener la siguiente gráfica, que muestra que la reacción es de primer orden, siendo la pendiente de las rectas el valor de K. Representando K frente a la temperatura, obtenemos la gráfica que pueden ver, que muestra una tendencia exponencial, tal como predice la ecuación de Arrhenius. En conclusión, se puede afirmar que la hipótesis es válida, ya que la reacción es de orden 1 respecto del ácido ascórbico, como predice la bibliografía. Esto quiere decir que la velocidad de la reacción es directamente proporcional a la concentración de vitamina C. Además, la velocidad depende exponencialmente de la temperatura, tal y como predecía Arrhenius.
Aunque las conclusiones eran sólidas y coherentes con el marco teórico, nuestra experimentación ha experimentado algunas limitaciones. Una de las principales es que la disolución de yodo empleada como valorante no es estable y hubiera sido más correcto estandarizar el valorante cada día, lo que no fue posible por las restricciones temporales. También fue complicado determinar el color exacto del punto de equivalencia, problema que podríamos haber solucionado midiendo el potencial de la reacción si tuviéramos el material. Finalmente, la vitamina C es fotosensible, por lo que procurábamos tapar el baño, pero hacía que la concentración de oxígeno no fuera constante y que parte de la luz degradase también el zumo. Se podría cambiar si tuviéramos una estufa de flujo constante de aire, donde aseguraríamos la oscuridad, concentración constante de oxígeno y temperatura estable. Este experimento nos ha enriquecido en varios aspectos, especialmente como indagadores, al investigar experimentalmente la concentración de la sustancia desconocida, como pensadores, al analizar resultados y compararlos, además de ajustarnos a los inconvenientes que se nos impusieron, y como comunicadores al trabajar en equipo y expresar con claridad procedimientos y conclusiones. Además, fomenta una actitud de responsabilidad en el laboratorio, conectando el aprendizaje con el mundo real. Por tanto, recuerda guardar el zumo en la nevera. Muchas gracias.
Finally, we call Maria Campos Buceta to illustrate us on a difficult chemistry topic, the effect of pH in the decomposition of hydrogen peroxide catalyzed by the catalase enzyme.
El efecto del pH en la velocidad de reacción de la enzima catalasa. ¿Sabías? Investigamos en qué medida afecta el pH a la velocidad de descomposición del peróxido de hidrógeno catalizado por la enzima catalasa. Y te preguntarás por qué es importante responder a esta pregunta. Las enzimas son esenciales para la vida, permitiendo que las reacciones en tu cuerpo se produzcan a la velocidad adecuada. Actúan uniéndose a una molécula llamada sustrato. En mi caso, el peróxido de hidrógeno, comúnmente conocido como agua oxigenada. La catalasa lo que hace es descomponer el peróxido de hidrógeno en oxígeno y agua, tal y como vemos en la reacción de la diapositiva. Sin embargo, la unión entre enzima y sustrato solo puede producirse si la enzima tiene la forma adecuada y esto depende del pH del medio y la temperatura. Por ello es importante controlar estos dos factores. La reacción de descomposición del peróxido de hidrógeno es de vital importancia, no solo en el cuerpo humano, sino en sus múltiples aplicaciones, como por ejemplo en la industria alimentaria. En la pasteurización, el peróxido de hidrógeno funciona como agente de esterilización. Sin embargo, el exceso de peróxido afecta al sabor, textura, fermentación de la leche. Por ello se añade la catalasa para eliminarlo. Según mi hipótesis, sí, el pH afecta a la actividad de la catalasa. La velocidad de reacción aumentará a medida que nos aproximemos a su pH óptimo. En cambio, al sobrepasar su pH óptimo, descenderá debido a la desnaturalización de la enzima, es decir, el cambio en su forma. Según los estudios que he consultado, el pH óptimo de la catalasa es el 7, pero depende de la fuente de catalasa utilizada. Procedimiento experimental. Para comprobar mi hipótesis empleé siempre la misma masa de levadura como fuente de catalasa, que añadí en el frasco de reacción junto con el mismo volumen de disolución del pH a estudiar. A continuación coloqué el frasco agitador en el agitador magnético y añadí
el mismo volumen de disolución de peróxido de hidrógeno, tapando el sistema rápidamente con el sensor que mide la concentración de oxígeno en el tiempo. Esta gráfica muestra los datos brutos de concentración de oxígeno frente al tiempo para cada valor de pH. Sin embargo, parece que en los primeros segundos se formase más lento. Esto es debido a que el oxígeno tarda en llegar al sensor desde el medio de reacción. Además, el pH 7 parece ser claramente la más rápida y parece que su velocidad empieza a estabilizarse. Por ello, para calcular la velocidad de reacción, voy a descartar los tiempos iniciales y finales, como podéis ver en esta gráfica. Considerando que solo los tiempos centrales, se puede ver cómo los datos parecen ajustarse a rectas. Como la velocidad es la variación de concentración frente al tiempo, cada uno tendrá su propia velocidad. Finalmente, para responder a mi pregunta, representando la velocidad frente al pH, se obtiene la siguiente gráfica. Parece que crece de forma exponencial hasta llegar a su punto máximo, que es pH 7, y luego vuelve a descender aumentando a medida que se aumenta su pH. Conclusión. En conclusión, como respuesta a mi pregunta de investigación, el pH afecta a la velocidad de la reacción de la enzima catalasa, aumenta de forma exponencial aproximándose a su pH óptimo, que según mis resultados es 7. Por tanto, mi hipótesis queda validada. Con este experimento podría ayudar en medicina a la detección de bacterias, incluso en las aguas residuales acelerar el proceso de limpieza. Mejoras. Aunque mis conclusiones son coherentes con el marco teórico, como toda mi experimentación, está sujeta a mejoras. Una limitación de mi experimento fue asumir que la temperatura ambiental se mantenía constante al realizar las pruebas el mismo día de manera consecutiva en el laboratorio. Sin embargo, sería más correcto utilizar un baño termostatizado. Es importante este control de la temperatura, porque uno de los factores que afectan a la velocidad de reacción y la forma de la enzima es la temperatura. Otra mejora del experimento se podría utilizar una fuente de catalasa más pura para que todas las muestras tendrían la misma concentración de dicha enzima. Además, sería interesante repetir el experimento, pero empleando valores de pH intermedios entre 6 y 8 para determinar con mayor exactitud el pH óptimo de la enzima. Además, gracias a este experimento aprendí a trabajar de manera organizada y con precisión científica. También fortalecí mi pensamiento crítico y mis habilidades de comunicación. Esta investigación me hizo ver cómo algo microscópico puede tener un gran impacto en nuestro entorno. Muchas gracias por su atención.
Thank you all for such interesting presentations. But now, after so much science in motion, we guess that your minds, and no doubt ours, may need some rest. Therefore, we invite you to a small breakfast break of only 15 minutes due to time management issues, and we will continue at 12:15 for the next round of presentations. Enjoy.
Welcome back to all of you after this nutritious pause, in which we may have managed to exchange views on the previous presentations and prepare for the next. Before resuming, we would like to remark the importance of your feedback, both online and in person, through the forms offered by link online and QR code in person. We thank you all in advance for your active role in the success of this Congress. The second round of interventions will be featured in this order by the teams from SEK Alborán, Cataluña, Ciudad del Campo, and El Castillo. Carla Herrera Santana is going to start by explaining the impact of wet acid deposition on plant development. Good luck.
Good morning, my name is Carla Herrera. I'm in first of baccalaureate, and I'm going to present my project about the effects of wet acid deposition on plant growth. Acid rain holds significant importance due to its profound impact on the environment and human structures. It threatens aquatic life, depletes soil nutrients which are essential for plant growth, and accelerates the decay of buildings and historical monuments. Furthermore, it poses health risks by contaminating water and food sources, highlighting the need for sustainable environmental practices. For this reason, I have carried out this project to better understand its significance and impact. Did you know that in the Carpathian Mountains National Park in Slovakia, a study conducted for the magazine Science of the Total Environment found that more than 70% of young conifers died from the cumulative effects of acid rain during the 1980s? Reading this article led me to wonder how great the effect of acid rain could be on crop growth, and that is why I decided to develop this project. This research examines how acid rain affects the growth of Lens culinaris by simulating different pH levels. Understanding these impacts is crucial as acid rain threatens ecosystems and harms agriculture. This project aims to highlight the importance of addressing pollution-driven pH changes to protect, in this case, the nature. To study the research question of how does water pH affect the stem growth of the Lens culinaris, I have formulated the following hypothesis and identified its variables. The independent one is the pH level in water, using from pH 2 to pH 6, taking into account that 5.5 and below is considered acid rain, and the dependent variable is the stem growth of the Lens culinaris. I had to follow these steps in order to carry out the corresponding experiment using different concentrations of pH when watering the Lens culinaris. Like I have said, using pH 2, 3, 4, 5, and 6. And after doing so, the plants grew, and I collected enough data to be able to create patterns of the difference in growth of the Lens culinaris. And here we can see how I calculated the percent of change using that difference. After doing this experiment, I was able to observe how low pH decreased plant growth, while pH between 4 and 6 varied. Thus, supporting the hypothesis I formulated at the beginning of the project. I have also evaluated the method, finding out what things have stood out, such as the reliability of constant variables and the use of various seeds, in addition to highlighting what improvements can be done, such as the sun exposure and a greater pH range. A valuable further area of investigation will be its impact on crop productivity. In the case of lentils, for example, this means measuring not just the plant height, but also the actual yield. How many pods and seeds are produced under acid rain conditions? This approach will offer deeper insight into the economic and agricultural implications, helping farmers and policymakers to better understand the risks acid rain poses to food security. During the development of this project, I have used different skills of the SEK profile that have helped me to do it, like the investigate rigor while understanding acid rain and its effects on plant growth through scientific testing, efficient communication applied to explain the results and conclusions using scientific vocabulary, critical thinking shown when interpreting the impact of different pH levels and evaluating the method, and self-regulation demonstrated by constantly following the procedure and tracking growth over time. These are the references used during the development of this project, and thank you for listening.
That was an excellent overview of a very complex topic. Now I want to ask you a question. Who among you normally eats while looking at the cell phone? Please raise your hands. Who normally eats while looking at the cell phone? Okay, please don't lie. I know that most of you. Okay, well, after Begoñas López Ibáñez and Eva María's Moya Maldonado presentation, you may reconsider doing so.
Buenos días, somos Begoña López y yo, María Moya. ¿Sabéis cuántas personas se infectan por causa del teléfono móvil? La conjuntivitis, la gastroenteritis, la faringitis, estas son algunas de las infecciones más comunes en España, que casualmente encontramos en la superficie de nuestros teléfonos móviles, ya que el 92% de los móviles encontramos bacterias y más del 90% de la población de España dispone de un dispositivo móvil.
Este estudio lo hemos realizado por nuestra iniciativa de ser futuras sanitarias, promoviendo la seguridad del prójimo e intentando llegar a la raíz de las infecciones. De esta manera, intentamos concienciar de la importancia de la desinfección de objetos comunes y donde pensamos que no existe un riesgo.
Los agentes químicos son capaces de controlar y eliminar los microorganismos patógenos que encontramos en la superficie y objetos. Estos actúan destruyendo la estructura de las células de las bacterias, virus y hongos, impidiendo su reproducción y propagación. Su uso es esencial para poder reducir la transmisión de enfermedades comunes, como se pudo demostrar con la pandemia del COVID-19.
Nuestra pregunta de investigación se basa en averiguar cómo afectan los desinfectantes al crecimiento microbiano que podemos encontrar en la funda de un dispositivo móvil, llegando a la hipótesis de que se reducirá gracias a la composición química de los agentes químicos. Teniendo como variable independiente los tres agentes químicos, la lejía, el sanitol y el antiséptico de manos, como dependiente el crecimiento microbiano y las controladas el agar, la temperatura, el tiempo y la cantidad de agente químico y la funda del móvil.
Lo primero que hicimos fue preparar las placas de Petri para poder cultivar los cultivos. Con una varilla esterilizada cogimos las muestras que necesitábamos para el cultivo, sin aplicarlo con ningún desinfectante. Con un spray rociamos una parte del móvil con él y cogimos las muestras con varillas diferentes. Por así, para cada desinfectante lo mismo. Por último, hacíamos visitas al laboratorio constantemente para poder tener un seguimiento del crecimiento.
En el día 9 se puede observar cómo sin desinfectante crecieron hasta 18 colonias, con antiséptico de manos 6, con el sanitol 4 y con lejía 3. Se ve en la gráfica un crecimiento exponencial en todos los casos, viendo cómo en algunos casos crecen más que en otros.
Con los datos podemos ver una disminución significativa del número de colonias al aplicar los desinfectantes, viendo cómo la lejía es el más eficaz, eliminando hasta un 83% de las colonias.
La evaluación de nuestra hipótesis dice lo siguiente. El experimento mostró cómo el uso de los desinfectantes químicos redujo el crecimiento microbiano, confirmando la hipótesis. La lejía fue el agente más eficaz, con solamente 3 colonias al día 9, mientras que el sanitol y el antiséptico de manos también limitaron el crecimiento 4 y 6 colonias respectivamente, comparado con las 18 colonias que crecieron sin el desinfectante. Por lo tanto, nuestra hipótesis se ha visto respaldada, ya que los desinfectantes químicos disminuyeron significativamente el desarrollo bacteriano en la funda del dispositivo.
La fortaleza, la temperatura, el uso del mismo tipo de superficie y el tipo de medio, el agarre en las placas de Petri, fueron variables constantes que estuvieron totalmente controladas. Se realizaron mediciones repetidas a lo largo de varios días, el día 1, el 3, el 5, el 7 y el 9, por lo que se vio claramente un patrón de crecimiento de los resultados. Se siguieron los mismos pasos para todos los desinfectantes, usando siempre varillas esterilizadas y aplicando los productos de la misma manera. Sin embargo, también tuvimos unas limitaciones. El estudio se limitó a solo 3 desinfectantes, por lo que la variedad de agentes químicos probados fue reducida. Todas las muestras se tomaron de un único dispositivo móvil, lo que puede limitar la generalización de los resultados a otras fundas con materiales o condiciones distintas. Se podría haber medido la cantidad de un solo tipo de agente químico en distintas concentraciones, para así saber cuál es la cantidad óptima de desinfectante.
Una posible área futura de estudio. Analizar cómo, por ejemplo, influye la composición química específica de cada desinfectante en la reducción del crecimiento microbiano. Por ejemplo, investigar qué compuestos activos, como el hipoclorito de sodio en la lejía o el alcohol en el antiséptico, son más eficaces contra ciertos tipos de bacterias presentes en la superficie del móvil. Las competencias del perfil SEK que hemos seguido son las siguientes. El primero, el rigor investigador. Ha sido necesario para poder comprender cómo distintos agentes químicos afectan a los microorganismos. Se formuló y se puso a prueba una hipótesis.
El segundo, la comunicación eficaz. A lo largo del informe de laboratorio fue fundamental presentar el contenido aplicando un lenguaje técnico y científico y transmitir la información de manera coherente.
El pensamiento crítico. Durante las prácticas de laboratorio es muy importante analizar datos y sacar conclusiones basadas en la evidencia. Fomenta habilidades como la observación, el análisis y la evaluación.
Y por último, la autorregulación. Para poder completar con éxito esta práctica de laboratorio fue necesario tener una buena organización y habilidades de gestión entre nosotras.
Estas son las referencias que hemos seguido para poder investigar a lo largo de nuestro proyecto. Y aunque con los resultados de la lejía vemos cómo es el más eficaz, hay que tener cuidado con ella, ya que al tratarse de hipoclorito de sodio en la disolución acuosa en la que se presenta, se disocia y se forma el ácido hipocloroso, que es el responsable de penetrar las membranas celulares y oxidar las proteínas, los lípidos y los ácidos nucleicos de los microorganismos, inactivándolos.
Pero a su vez hay que tener cuidado si esta entra en contacto con la piel, ya que al igual que inactiva los microorganismos patógenos, también daña nuestra microbiota normal, la cual es beneficiosa para nosotros. Muchas gracias por su atención.
Thanks for bringing such a valuable presentation perspective to the table. Now students from SEK Catalunya are going to illustrate us on the effects of location on the air purity in ppm of carbon dioxide. Please, we call Leo Connolly and Esteban Mut.
Ya.
Sí.
Vale. Y ahora esto porque no se va. Ah, espérate. Ahí.
Yeah. So, hello everyone. Today we'll be presenting our mock internal assessment that we perform in the integrated sciences subject, talking about ecological problems.
So this is a little basic subject surround before we start actually working on to the actual thing. So the objective of this experiment is to see the chemical composition of pollution of the air, specifically carbon dioxide, in different air purity locations. I'll explain these now, but you can refer to the image at the left if you want to know what they are. In the picture, there are 6, but we only investigated in 5. So what are air purity locations? As you can see, here we have 6. Natural sources, home heating, industrial, indoor sources, traffic, and outdoor burning. What this means is that there are 6 various locations in which carbon dioxide is produced in a regular constant matter, even though they are in different quantities. And then we want to see if the different concentrations of these, which we'll measure, could then affect a system of human lungs.
So our investigation question was, how does the type of environmental location affect the air purity? The variables we measured throughout the experiment was the independent one, which was the type of environmental location, which Leo mentioned previously. There were 6 examples. Then there was a dependent variable, which is the air quality. We focused on the concentration of carbon dioxide particles per million. And then the control variables was the amount of air taken in the sample, the type of system. In the case of our experiment, it was a closed system, and the total surface area of the system.
So then we had 5 different hypotheses, 5 for each different air system we measured. And then the general gist of them, all concentrated into one, was if the air is extracted from a more natural or open air source, basically meaning there's more ventilation or more oxygen currents, then the particles per million, which is in a million particles of the air measured, how many of these are made of carbon dioxide, how many of these are carbon dioxide, then the number will be lower due to the nature of outdoor environments with higher ventilation and higher dispersion of carbon dioxide, while if it's more industrial or an indoor space, this concentration will be higher, therefore indicating bigger impact on human lungs and health.
So the method. The first step we took was gathering all the materials, in which we used 5 bottles and 5 makeup removal pads. The bottles were empty, and then we inserted 5 makeup removal cotton pads at the bottom of each bottle and closed the system. The second step consisted of us going to those 5 different environmental locations, taking a sample of the air right there, and closing the system. Then the third step was letting the samples throughout 1 whole week, so it had time to act the concentration of carbon dioxide. And then the fourth step was at the end of the week, using a carbon dioxide measure. We measured the concentration inside of each of the different bottles, and so we had the concentration of the particles per million of carbon dioxide.
Now, these are the results we obtained. Due to the nature of the measuring, their results will be very similar, but I'll explain each of them. And even though they may look like simple differences, the difference in the carbon dioxide, even if it's for a few units, is a lot. The first example was the home heating, as you can see here. It was actually the third highest one. What this means is that home heating, what it has, it can either be supported by renewable sources, which are less often, or non-renewable sources, which by themselves produce carbon dioxide. We can find these in any system indoors that has an artificial way of heating up. Second one would be indoor quality. This was measured in a classroom in the school. What this means is that it has no ventilation, but at the same time, it doesn't have any external factors acting upon it. It is a closed system. And what this means is that the amount of people breathing and therefore producing carbon dioxide through cellular respiration makes the average particles per million rise up, even though not as much as the other systems. The lowest one was the outdoor quality. This meaning we went outside to a school forest, then gathered it there from an open system and then enclosed it into a closed system. This was the lowest due to the reasons explained in the hypothesis. Due to the outdoor air currents and our oxygen dispersion, there was less carbon dioxide. Next was outdoor burning, which was a high particles per million, but for a different reason. What happens when you burn something is that there's of course, the combustion chemical reaction. And what this does is it takes oxygen and then produces it into carbon dioxide. Finally, there's the industrial air quality. This one was the highest due to what we explained before, that most industrial systems use non-renewable sources which produce carbon dioxide and therefore increase their particles per million.
So how is this experiment linked to environmental issues we're facing? So we know that there's a problem in the atmosphere with the greenhouse effect of the carbon dioxide. And so to stop that, we need to understand what makes the carbon dioxide concentration be higher in the atmosphere. So that's why we did the experiment. And we went to all of these different places, and we were able to see that in some places there was a higher concentration of carbon dioxide per particles per million. And so we analyzed in that place what could possibly be a factor that increased the concentrations. And so once we knew what factor it was, we tried to reflect on how we could make this factor become less important, and so there will be less concentration.
And then finally, a brief final conclusion, answering a few questions. The first was the hypothesis evaluation. Our hypothesis was correct. The reasoning we used were the actual sources for the different numbers of particles per million. The only mistake we had that we then changed was the fact that even though in the specific hypothesis, for a case of outdoor burning, we referred to combustion, in the general hypothesis, we didn't refer to external factors like combustion or chemical reactions. The method was correct, and a very good strength it had is that even though it was enclosed during a week, the measurers were already inserted into each of the bottles, so as to when it was actually measured, there wouldn't be any air dispersion, and the air from the bottle would be the exact same from the environment. The information extracted matches with our previous research and matches all of our results, then leading to a conclusion that these different concentrations in environments can lead to lung damage, and extensions would be measuring it with different air locations or investigating more further upon what exactly causes these concentrations. These are the sources we used for the previous research we explained at the start and to back our hypothesis. And a special thanks to our teachers, Marina de Jong, Bernardo Marias, and Cristina Villaverde. Thank you.
Yes. Before continuing, please remember that the Mentimeter is open. So in between presentations, we truly suggest you to keep answering the questions. The QR code will be in a few seconds besides me, or if not, you've got the blank sheets of paper with the QR code rolling through the room. And now, said so, continuing with the list, Julia Vidal and Irana Gireke are going to tell us about our physics project, which I'm convinced that both Diego and Mr. Anaya will know much more about. How does the mass of an object affect its acceleration while sliding down an invariant ramp? Well, you will know the answer in a few minutes.
So, vamos a presentar nuestro internal assessment que hicimos en la clase de Ciencias Integradas con Ainara y yo.
Lo que investigamos como pregunta de investigación teníamos cómo influye la masa de un objeto en la aceleración del mismo descendiendo por un plano inclinado manteniendo el ángulo y la distancia.
Pues los objetivos que nos pusimos al hacer este experimento fue entender la segunda ley de Newton relacionada con las fuerzas que actúan sobre los objetos y entender las aplicaciones de la física acerca de las fuerzas y el movimiento.
En este caso teníamos como variable independiente la masa del objeto, como variable dependiente la aceleración, y luego teníamos tres variables de control. El ángulo del plano inclinado, en este caso 30 grados, gravedad, que es, cogimos los dígitos de 9,807, y la velocidad inicial.
La hipótesis que planteamos para este experimento fue que si un objeto desciende por un plano inclinado, que sería una de las variables de control bajo condiciones gravitatorias constantes en la Tierra, otra de las variables de control con una velocidad inicial de 0 metros segundo, otra variable de control, la aceleración, que sería la descendiente, será independiente de la masa del objeto, ya que está determinada únicamente por el ángulo del plano y el coeficiente de fricción si lo hubiera.
Después, como procedimiento, lo vamos a explicar un poco por encima, pero básicamente lo que vamos a hacer era medir las masas de los objetos, el tiempo y la distancia recorrida varias veces de cada objeto para así después poder calcular la aceleración promedio de cada uno.
Bueno, pues una vez terminado el experimento, hicimos estas tablas de resultados y, bueno, tras realizar el experimento, los resultados obtenidos no permiten conformar la hipótesis realmente planteada. Por lo tanto, nos indica que hay otras fuerzas que han afectado a los resultados, que esa fuerza sería el coeficiente de fricción o rozamiento. Como vemos en la tabla de abajo, los objetos con coeficiente de fricción positivo, es decir, la bolonia, la goma de borrar, etc., tienen menor aceleración, lo que demuestra que la fricción contribuyó a reducir la aceleración de los objetos.
Luego, como análisis del método, tenemos que varios errores humanos, como por ejemplo cronometrar, ya que no podemos darle exactamente cuándo empieza y cuándo acaba. Eso quiere decir que hay un margen de error a la hora de mirar el tiempo. También otro error humano era el que se haya dejado caer justo al inicio del plano inclinado. Como eso no lo podemos controlar exactamente, había ese margen de error de a lo mejor milímetros que también hacía que no fuera exactamente adecuado. Después, uno que ya no contemplamos muy bien fue el desplazamiento con rodamiento no lineal. Que esto sucedió ya que habían objetos que en vez de deslizarse por el plano inclinado, lo que hacían era rodar, entonces no es exactamente lo que buscábamos, de que había un margen de error.
Y una vez terminado toda la evaluación, pues nos planteamos algunas mejoras para futuros experimentos similares. Y, por ejemplo, se debían de controlar más estos factores humanos, como parar el cronómetro justo en el momento. Para esto podríamos repetir el experimento más veces, pese a que ya lo repetimos 3 veces. Creemos que si lo hubiéramos hecho más, la media de los tiempos sería más exacta a la realidad y nos dejaría tanto margen de error.
Como conclusión podemos decir que las fuerzas que actúan sobre el cuerpo o objeto que se desliza en un plano inclinado tienen influencia en la masa de este. Aunque la masa no afecta directamente a la aceleración, tal y como hemos demostrado en una parte teórica que se hizo previamente antes del experimento, los diferentes coeficientes de fricción entre los objetos utilizados del plano inclinado han influido en estos resultados. Por ejemplo, el coche tenía menos coeficiente de fricción, lo que hacía que la aceleración fuera más rápida. En cambio, otros objetos con más coeficiente de fricción hacía que se ralentizara esto. Tenemos varios, bueno, esos son 4 links solo, pero habían mucho más de donde hemos sacado la información. Y bueno, gracias por vuestra atención y queremos darle los agradecimientos a Mariana Villón, sobre todo porque es la que más coordina este experimento.
Next in row is Sectio Alcampo, another physics project. Pablo González Álvarez Payete, David Yuyang Wu, and Max Sánchez Seipler are going to explain the sound diffraction through a classroom door.
Good afternoon, everybody. We are David Yiyang Wu, Max Sanchez-Sapler, and myself, Pablo González Álvarez-Payete. And today we are going to present you our investigation about sound diffraction through a classroom door. This investigation is from the scientific field of physics, more specifically from the part of sound and wave behavior.
So for this experiment, we wanted to measure how much did the opening of a door affect the refraction of sound that's outside of that door, and in turn also affect the sound intensity that is heard inside of the room. We did that with a speaker that emitted a constant 880 hertz and was at a constant distance from the classroom we were using.
Our hypothesis is that there's going to be an optimal opening in the door where the sound intensity is going to be at its maximum.
So the variables for our experiment are the following. First, we have the dependent variable, which is the opening of the door. We initially wanted to measure it in degrees, but we then decided to settle for centimeters, as we thought it would provide a much more accurate way of measuring the amount of opening in the door. Then the dependent variable is the sound intensity, which is in decibels. And we have three control variables. The first one was the position we were in the room while taking the measurements. So we were at a constant distance from the classroom door where the refraction was happening. Then the sound frequency, as we said earlier, it was 880 hertz. And the speaker volume was also a very important control variable, as we all set it to be constant so it wouldn't impact our results. So for the experiment setup, what we did, as you can see in the image there, we placed the speaker at 14.53 meters from the classroom door. A possible error there was that there was a bush in the middle, but we did take that into account while doing our calculations. Then we placed ourselves, and two of our classmates, well, me and my friend David, went inside the room and started measuring the sound intensity at exactly 5.57 meters of the door. For the procedure, what we did was every 15 seconds, we would open the door by 5 centimeters, then measure for 15 seconds again. So we would have a good and accurate measurement, and then we calculated the average of sound intensity in those 15 seconds. We did that for trials.
Okay, so the safety precautions we took. Being exposed to high pitch and high decibel sounds will affect your hearing. It will maybe cause tinnitus or even permanent hearing loss. To prevent this, we used, as you can see in the image under there, we used noise-canceling headphones, and the people inside the class used earplugs, as we didn't have enough headphones for everybody. Okay, so the results were that there was an increase until the 10th centimeter, and then there was a slight drop. The quadratic fit of our experiment was a strong 0.9882, which meant that it was pretty reliable. And still, there were things we couldn't control and affected on the results. The phone mics are imperfect and may cause different problems. Buzzes and echoes might have interfered in our results. And also tiny changes as in how the phone was held and where was it placed could affect the results. If we did it again, we'd use more professional equipment and try it in a quieter space for more precise data. And to conclude, the results do support our hypothesis, as there is an optimal opening at 8.62 centimeters, in which there is a 52.22 decibel sound inside the room. And if but we will need to do it again with more precise data and more precise equipment to further prove our hypothesis. Thank you for listening. Sure.
I don't want to put you on the spot. I'm just
different angular positions. So you didn't actually explore how the weight spread.
So yes, we originally intended to do that, but then we had like a time constraint because we didn't have a lot of time to do that experiment. So we ended up settling with well, that one measurement, and if we would do future experiments, we would do that from different angles from the door.
We. Yeah, I was
going to. So you're looking at the diminution of the sound. That the more it spreads, you've expected the sound intensity to decline. Is that right?
Not exactly. So what we wanted to see is what point of opening in the door would the dimming would I don't know how to explain. So at what point of the opening of the door would the sound be most heard in the room? And of course, that is kind of inverse of refraction, because the more refraction, the less you hear it, because it's more spread around through the room. And, well, we came to the conclusion that, well, as you can see there, but of course, nothing like the sound intensity was at its most when the door was opened. So.
As well as to the question before, we were only 3, as you can see. Like, we are the only people, as well as Gloria, our teacher, that work on this project. And we only had my phone and his phone. And my phone was used to generate the sound. Therefore, we only had one mic we could use. And as we said in improvements, if we could, we would use more precise and professional equipment. But we didn't have, we also had the time constraint. So we didn't have enough time and equipment to do different trials with different distances of the mic.
I'm sure that many of you have at some point not brushed your teeth after drinking a sugary drink. Ana Camarero Rubín, Lucía Gamella Gutiérrez, Marta Azul González, and Noa Huertas Núñez will explain in a bit the consequences, so please come up to the stage.
Have you ever thought about what your favorite drinks might be doing to your teeth? Hello everyone, today my colleagues and I are going to present an experiment in which we use eggshells to simulate our teeth and see how drinks we consume daily affect our tooth enamel. And believe me that you are going to be very surprised with the results. We did this with the objective of investigating the components of different drinks and see which ones are the most, cause the most damage to have the knowledge for a better oral hygiene. For that, we use lemonade, Coke, coffee, pineapple juice, chamomile, Monster energy drink, and water, because we need it for control as it is a neutral variable. Before starting the experiment, we have to do a profound background research. And we started by asking, well, what is the tooth enamel and why is it so important? We discovered that the tooth enamel is the hardest substance in our body and that it is actually made of a mineral form of calcium carbonate. We also discovered that therefore it is, although it is very strong, once it is hurt, it cannot be recovered again. So this information makes extremely important protecting it for a long-term dental health.
Okay, so why are we using eggshells as a model? They're very similar to human teeth in one way, and it is that they're both made of a material that reacts with acid. Eggshells are made of calcium carbonate, just like the enamel, and when calcium carbonate gets in contact with acid, it creates a visible reaction, and bubbles come out, and it starts to fizz. This is due because of the release of carbon dioxide, and the surface is being eroded.
So the last questions we need to answer in our background research was, how do these drinks actually affect our teeth? So when we have drinks, we have soda, juice, and energy drinks. They're basically categorized in two things. Acid drinks and sugary drinks. And acid basically breaks down the mineral that makes your tooth enamel, while sugary drinks feeds the bacteria that makes more acid, so we go back to breaking down the minerals. So this, if consumed over time, can lead to stains, damage, and irreparable damage.
Okay, so continuing with the variables. Okay, so we divided our experiment into different variables. We have our independent variable, which are the type of beverages that we're going to change. We have our dependent variable, which is the color and the integrity of the eggshells. And then we have control variables, which we're going to keep the same during the whole experiment, which are the exposure time, 72 hours, the volume of the beverage, 60 milliliters, and the number of samples, which are going to be 2 eggshells per drink. Oh, okay. And now continuing with our hypothesis. Okay, so we believe that Coca-Cola and Monster are expected to cause the most eggshell damage due to the high acidity because they're so very high in sugars. And there are also other beverages such as pineapple juice and lemonade, which are very high in acids, and they're also going to cause a significant change. Water will serve as a control, and it would have no significant changes.
At the start of the experiment, all the eggshells were clean, smooth, and white. Each one weighed exactly 2.6 grams and had no visible damage. After 72 hours in the different drinks, we could clearly see major changes in some of them. The eggshells in the water look almost the same. No color change, no foam, and the shell stayed hard and white. However, the eggshell in Coke became much darker, and the surface turned rough and fragile. The same happened with the shell in Monster, which also showed a lot of surface damage. This drink caused not only a visible change, but also a chemical reaction. We could see foam and bubbles forming during the experiment. Which shows that the acid in the drinks were created with the calcium in the shell. In lemonade and pineapple juice, the eggshell also changed color and produced bubbles, showing that the acidic drinks can damage enamel. The shell in lemonade became more yellow, and in pineapple juice it became softer. The shell in coffee changed color as well. It became brown, but didn't show as much surface damage as the other. In the end, we waited, and the shells again, the ones in Coke and Monster, had lost the most mass, providing that this drink caused the most enamel erosion. The comparison between appearance and weight of the shells before and after show how damaging can be these drinks to our teeth.
So why is it important? As we said in our hypotheses, we theorized that the Monster and the Coke would be the one that had the most damage, and we see just that. Especially with the Monster, with its acidity, it caused a great damage to the actual shell of the egg. So we came to the conclusion also that if the drinks had colorant, like for example coffee or Coke, which had a more darker tone, the eggshells would have colorant too at the end of the experiment. And if the drinks were more acid, the eggshells would have more structural damages, as we can see in the Monster and the lemonade. So this may all seem so far to you. I mean, you're not going to spend your teeth 72 hours in a Monster drink, of course not. But we did some calculations, and if we divide by the days and hours and everything, and the amount of time per average that a person spends consuming a Monster or a coffee, which is the two we made the calculations for, in a Monster, it would amount to around 2.7, 3 Monsters every week. So obviously, there's a huge margin error. Like, every time you drink, you're not spending the whole time in the drink, you're actually drinking it. And these drinks were actually all the time there, so there's an additional thing. But imagine, 3 Monsters a week could cause that to you. And even if it's not 3 Monsters, every year we eat. And you may say, well, Monsters are very different from what I eat normally, but coffee, which is the other thing, was 6 cups of coffee a week. I'm pretty sure most of you drink more than 6 cups of coffee, and even if you don't drink more than 6 cups of coffee, you would end up increasing a lot. So are we still going to consume these drinks, knowing that the damage we can pay is that, knowing that's the price we have to pay? Thank you.
Yeah.
we searched it on Google. Like, we searched the average time, and we got our results, so we based it off of that. So if you want to know, it was like for Monster, in casual drinking, it was half an hour, more or less, and in coffee, for also casual drinking, it was like 13 minutes. 13.
Sadly, presentations are about to finish. My school will be the last to present. My peer, Nathaniel Hopkins, will give us an insight on acid conservation of kombucha of different tea types.
Good afternoon, everyone. I'm going to be explaining how different tea types, these 5 up here, affect the acidic acid concentration of kombucha. Okay, so what is kombucha? Kombucha is a drink that was made in the Qin dynasty in China. It was then found by a Korean man who brought it to Korea and made it more widespread and more popular. It died down in World War II due to the limitations of tea and sugar, but then in the 1990s, hippies in America started refining the tea and finding the benefits behind it, and now it is commercially sold and bought. Okay, so these kombucha can be made in thousands of different ways. It can have so many different things in it, but every kombucha has these 4 base bacteria: xylem, acetobutyrar bacteria, lactic acid bacteria, and Baker's yeast. Okay, so to understand how this experiment works, you need to understand what a sodium hydroxide titration is. Acidic acid naturally has a low pH of around 3, and sodium hydroxide, NaOH, has a high pH of 14. So to calculate the amount of acidic acid, what you do is you slowly add in sodium hydroxide until you've reached the equivalence point in which the phenolphthalein has reacted. And as you can see, there's a big color change between the two. Okay, the methodology. What I did was I created many different tea types. I made kombuchas of all these different teas, and I let them sit and ferment for 2 weeks. From then, I used the acidic acid titrations to determine the amount of NaOH needed to neutralize the acidic acid. In this experiment, I had 2 different hypotheses. The first one is related to the oxidation. The more oxidated a tea is, the more acidic acid it will produce. So teas such as red or black tea will produce more acidic acid. My other hypothesis was that added ingredients into the tea will reduce the amount of acidic acid. For example, a tea that I used with added ingredients was chai, and it wouldn't produce much acidic acid due to the fact that the added ingredients in it would inhibit the reaction of the bacteria in the kombucha. Okay. So this was my data, and as you can see, it in a way follows the hypothesis, but there are some anomalies and other factors. Green tea had the lowest amount of sodium hydroxide needed to neutralize it, which means it had the least amount of acidic acid. This goes along with the first hypothesis that states that teas with less oxidation would produce less acidic acid because green tea doesn't have a high amount of oxidation. The next one is chai tea, which is an anomaly because it should have been the first one because the added ingredients in it should have inhibited the reaction of the acidic acid bacteria. The third one was chamomile tea, which was also not supported by the hypothesis because it's a floral tea, and floral teas don't have any oxidation. So according to the hypothesis, it shouldn't have created much acidic acid. The red and black tea, as assumed, had the most amount of acidic acid in them, and that's because they had a high oxidation and they didn't have much added ingredients to inhibit the reaction. Thank you for listening.
Anna Cherniak, Li Yong Su, and Zijing Wang will finish this round of marvelous projects by explaining the impact of natural antibiotics and bacterial growth.
Hello, everyone. We are Anna, Lily, and Linhon, and today we are going to present you our project, The Effect of Natural Antibiotics on Bacterial Growth. These are our contents that we are going to explain today. So that's introduction, research question, hypothesis, background information, meta steps, results, discussion, and conclusion. I'll start with the introduction of our experiment. Antibiotics resistance is a growing global problem. Our experiment investigated the natural effects of natural substances such as garlic, honey, and vinegar on bacterial growth, as they were traditionally used in medicine. We are gonna tell you the effect of these antibiotics on bacterial growth. The aim of this experiment was to evaluate the effectiveness to inhibition of bacterial growth, and the purpose is the experiment may provide insight to the potential as natural alternatives to synthetic antibiotics. And the research question is how do each of the natural substances, which are garlic, honey, and vinegar, the independent variables, can affect bacterial growth, which is dependent variable, and the site of inhibition zone, as consequences of antibacterial compounds over 24, 48-hour period.
Okay, so I'm going to talk about the hypothesis. The garlic and vinegar, they can inhibit bacterial growth. And for example, garlic has the largest clean zone in order to disrupting bacterial growth. And vinegar, he seems a bit different because he's used moderate effect to reduce growth. But honey, it seems different because honey, he has the weakest inhibition. So background information. Bacteria grow through binary fusion, like thriving in environments in optimal condition. And some natural substances like vinegar, honey, and garlic, they have their own antibacterial properties in order to disrupting bacterial growth. And studies suggest they could be alternative to synthetic bacterial because they can aiding in fight against the resistance. And finally, like in 1910, antibiotic began, but in 1928, Fleming discovered penicillin, which is a natural antibiotic.
These are our method steps. So firstly, we prepared gelatin medium. For this, we boiled 70 milliliters of water and dissolved there 10 grams of gelatin, 4 grams of sugar, and poured into Petri dishes and refrigerated until it was set. But this is proportions just for one experiment, which is like 4 Petri dishes, one with garlic solution, one with honey and vinegar, and one is control with water. But we did this experiment 3 times, so we need 3 times more ingredients. Then we swept bacteria from cooked rice and applied to gelatin surface, labeled dishes with the initials of the antibiotic that we used in each of them. So garlic, honey, vinegar, and control, it was like just with water. Then we prepared antibiotic solutions with garlic, honey, and vinegar, and soaked cotton pads in them, and put these soaked cotton pads to the petri dishes which contained bacteria. Then we incubated our petri dishes with bacteria and antibiotics in room temperature for 48 hours. It was a dark place because it is better for bacterial growth. Then after the time passed, we observed the results, took photographs, and measured bacterial growth. And then we disposed material safely and disinfected our work areas. We took photos and we changed the presentation a little bit, but I don't know why we don't have any photos and changes here, so I don't know. Sorry about this.
Okay, so these are the results that we obtained. As we mentioned before, we measured the inhibition zone of each of natural antibiotic and recorded them into the tables and represented into a graph. So based on the results, we can see that garlic is clearly the most effective natural antibiotic among these 3 extracts that we selected. It maintained the largest inhibition zone, which was 42.33 millimeters as the average of the 3 samples that we tried for each extract. So it means that it demonstrated the strongest antibacterial property. Then it is followed by vinegar. It demonstrated 33.67 millimeters of inhibition zone as average, which means that it has a moderate effect against the bacterial growth. The weakest one was honey. It maintained a 24 millimeters of clean zone, which means that it has less antibacterial property than the previous 2, but still it is effective against bacterial growth. The last one was a control sample, which was not treated, and it demonstrated that if it is not treated, then the bacteria would cover the whole petri dish, reflecting that the previous 3 were actually effective. As conclusion, our experiment effectively determined the effectiveness of natural antibiotics, and our results supported our hypothesis that we mentioned before. The data that we obtained were highly reliable, as the number that we obtained from the examples were similar, and the number of standard deviation were really small, which means that there is really small error scales. Future improvements that we propose that we could have done better is to improve the accuracy of measurements. Also, we could compare different acidic solutions, because in this case we only chose vinegar. And also, we would want to prove whether the bacteria were actually killed or just stopped growing. For future investigations, we propose that we could determine its long-term effect to prove whether they are actually efficient for antibiotic resistance, and also to try different concentrations of solutions to see if we can manage the effectiveness of them. And thank you for your attention.
Once this series of outstanding presentations have concluded, we will continue with a roundtable discussion featuring Don Juan, Gordon Wilkinson, and 2 students from SEK Alcampo and SEK El Castillo. And of course, the participation of our special guest, Dr. Miguel Anaya. The topic to be discussed will be the following: data visualization in scientific research, techniques and tools to make scientific data more understandable and engaging. So now I'm going to be explaining the dynamics of the round table. I'll pose a question and different schools will be answering. And you, Dr. Miguel, can intervene whenever you want to give your personal and professional insight about the topic. So please, I call the members to go up to the stage. Donde queráis. Okay, so we will start with Atlántico. Lola, scientific data must be communicated in a clear and understandable way for different audiences. What are the best practices for communicating data effectively, and which tools are the most useful for achieving this?
First, I think about who I'm talking to. If they're not scientists, I use simple words and avoid technical language. I try to explain the main message clearly, what the data shows and why it's important. I often use charts or images to make it easier to understand. I also like to tell a short story. What is the problem? What did the data show? And what does it mean? I make sure to say where the data comes from and if there are any limits or doubts. To help me, I use tools like Canva, PowerPoint, or Genially, depending on what I need to show. My goal is always to be clear, honest, and easy to understand.
Thank you very much for that intervention. We will be continuing with Alborán. So, Eva Maria, in today's world, as you may know, social networks are increasingly important, and people believe what they see in the internet without contrasting the information with other sources. How could we make this scientific data more attractive to compete with this pseudo data that is so easily accessible to the general public?
To make scientific data more attractive and compete with misinformation online, we need to rethink about how we communicate science. Misinformation spreads quickly because it's easy, it's emotional, and easy to understand. Scientific data, on the other hand, is often buried in complex language or academic journals. We can fix this by using storytelling, visual platforms like TikTok and Instagram, where misinformation thrives, to share accurate context. Scientific should learn to explain their work clearly, collaborate with trusted influencers, and use engaging formats like infographic or short videos. The goal isn't to simplify the science, but to make it more readable, accessible, and visible to the public.
Thank you very much. Yeah, Miguel.
You are speaking about social media. Do you know which are the two social media that are mostly used for science communication? Anyone in the audience can answer as well. Maybe the first question, which is the social media that you use the most?
I use more TikTok and Instagram.
Okay.
For communicate and be like communicate with the world and know about how it's happening right now.
Okay, so TikTok, Instagram is the most used among your, right? So,
yes.
Like professional research is communicated first in Twitter and second nowadays more often in LinkedIn, okay? So if you want to know about science, go there.
Okay.
Thank you very much. Leo Connolly from Catalonia. How can we ensure the reliability of scientific data visualization?
Well, in my opinion, to make scientific data visualizations reliable and correct, it's very important to make sure the data comes from a trustworthy or accurate source. If the data isn't reliable, then the conclusions, or it doesn't matter if they look good or not, the conclusions won't have the correct meaning due to a wrong base. And the most important step, in my opinion, it has to be able to be clear for the visualization so that anyone can understand it, even if an expert can understand if it's in a more complex format.
Thank you. Mr. Anaya, would you like to add anything else?
Something very important about everything that you are learning is that in science, it is key that anyone in any part of the world can reproduce what you are doing, okay? Another thing, one of these comments that, like, similar to one of the references and acknowledgements I was telling you before, most of you miss from where you are buying, I don't know, honey or the water or whatever you are using in your experiments. If I want to reproduce what you did, I may buy whatever, like the Coca-Cola. Instead of Coca-Cola, I can buy Pepsi, and I can think, okay, it is the same, but maybe it is not the same. Or is it Coca-Cola normal, or like the standard one, or is 0, 0, 0? All this information is very important, okay? Where did you buy these things? Is it in Spain, or is it somewhere else? Because you know that the content of sugar depends on where you are. So, I mean, this is an example about the beverage or the honey and all that, but many of you didn't put from where you are taking the equipment or your elements for the experiments, okay? It's very important.
Yeah, sure.
Thank you. I'd like to make the other point that when you're doing research, you're exploring the unknown. You don't know what the result is going to be. And that can make you anxious. And you can become worried. Am I getting the right answer? What should it be? And then a very natural reaction is then to appeal to an authority figure. Could be father, could be a teacher, could be your professor. But what you should be appealing to is the data. The data is the final judge of your experiment. Yes, as Dr. Miguel has often said, we have to acknowledge the role of our teachers, our professors, in training us. But what they're training us in is the capacity to analyze the data. They are not the ultimate authority. Your experiment might prove them wrong. How you actually then determine the reliability of your data, well, that's another question we might come to.
Yeah. Thank you very much for that positive feedback. So please, students, for your next research projects, keep that in mind. Now, from Ciudad del Campo, Adrián, continuing with this previous question, how can data visualization improve communication between researchers and the general public?
Well, Carla, thank you. Thank you for giving me the speech. I think this is a really interesting topic, and it's something that we should really take in mind. And I think we should really give a turn on how we expose our experiments, since the main idea of an experiment is to find a solution and be able to communicate it to the most people possible. And we commonly associate science with numbers, graphics, and data analysis, and it might not be the best way to concern our public on the problem. We should probably start introducing more visual or practical experiments and results that enable anyone, just by seeing an image, to understand fully the problem that is being investigating. So to give you a brief example and that everyone can understand it better, my partners from SEK del Campo exposed an experiment comparing the tooth enamel with the egg, and they basically just gave you they explained you fully with just an image and some examples how different beverages affect our teeth. And this type of results would enable us to have a better communication. Thank you.
Sharing is key. Therefore, that's why we do these kind of initiatives of the Scientific Congress, so that lots of students can understand our different projects. And then, Lincoln, do you think the way data is visualized can improve communication between the public and researchers? Or is it the other way around? And can the way it is presented actually inspire students to pursue their scientific goals?
I would say that it is definitely a way of improving the communication between researchers and the public, as it is a way of bringing scientific data closer to everyone. For example, the most commonly used tools like graphs or charts, they're used to simplify the data that we collected and to summarize it. And once the complex data is simplified, it can be transmitted with more clarity or to transmit it more directly. Also, it can also enhance the effectiveness of communication and make it more striking, as in timelines and comparison photos, which can give the public a more defined picture or idea about how is the result obtained or what is it about. But I also think that it is a way of inspiring students, as it makes us don't have to face too complex data, those that seems to be really complicated, but we are faced to like clearer and simplified information, which can be easier to inspire students and motivate them to explore or to investigate new fields by themselves, as it gives them the impression that science is not that much a complex matter that one would imagine.
Thank you. Miguel, continuing with this conversation, I would like to ask you a question. How do you disseminate this sort of knowledge between the public and researchers, between your team?
This is a very good question. Let's start with what you have been learning for this project, let's say. You have learned how to communicate science with a manuscript, am I right? You have written a dissertation. You have prepared a poster, and then today a talk, right? Let's only choose two of them, because the poster is between the manuscript and the talk, okay? In the manuscript, which is more like, it has to be more professional, more let's say, scientifically rigorous if you are going to share it with your researcher peers. The focus should be in what is written and on the figures, okay? But more importantly, the written stuff, and then you cite the figure. Figures need to be consistent themselves, but what is important is the discussion and the introduction that you write. In contrast, in a presentation, you need to focus on figures and in an oral presentation, on the speaker, okay? And this is a very common, let's say, point to improve for early stage researchers. You don't need to write a lot of text in the slides, okay? If you want to communicate effectively, what the people should focus on what you are saying, on what you are telling, and the message you want to say in words, okay? In what you are orally communicating. Presentations should focus on figures, schematics. Avoid pictures, avoid photographs. Make schematics with, I don't know if you know Blender or Inkscape. These are free softwares that you can use to prepare good figures. Learn how to use them. There are a lot of tutorials in YouTube. This is very important, okay? So you need first to know to whom you are speaking and which platform you are using. It's not the same to use something, manuscript or oral communication. Example, in a manuscript, which I'm not sure how you prepare them, but if you have read research articles, first thing is the abstract. Okay, first thing is an abstract. The translation to Spanish is resumen, ¿vale? No es una sinopsis. It is not a synopsis of a film. And this is a very, very, very common mistake. People say when you are in an early stage moment of your research life, in a manuscript you explain what you want to do. No. In a manuscript, the first thing is to explain what you did, which is the final result in a summary, okay? Whereas in a presentation, in an oral presentation, you reveal the results at the end, okay? It's more cinematographic, if you want to say like this, okay?
Yo os hablo en español, que hay mucho nivel aquí de inglés, ¿no? Era daros una idea, el científico, bueno, igual que todo en la vida, hay que ser publicista. Tú tienes que vender tu producto para llegar al público a quien quieres vendérselo. Tienes que lograr convencerle que tu idea es lo mejor, lo más interesante y cautivarle hasta el final de la exposición, y si logras esa presentación cinematográfica con la sorpresa final, le vas a grabar en su memoria el mensaje que pretendes. Hay que ser comunicador, hay que saber presentar mediante estos sistemas de pósters o breves comunicaciones, pero es que me estaba viniendo a la cabeza cómo llegué yo aquí o a ser biólogo. Pues cuando yo tenía vuestra edad, en Televisión Española había un señor llamado Félix Rodríguez de la Fuente que nos hacía unos programas maravillosos que cautivaban y que enganchaban y que creó toda una promoción de gente dedicada a la biología, que nos buscaba la biología, nos llaman. Eso es lo que hay que buscar, comunicar ideas por el método que sea, pero siempre pensando en que quieres convencer a la gente del producto que estás intentando venderles, entre comillas. Y sin remontarnos a la antigüedad de Félix Rodríguez de la Fuente, actualmente ya tiene 90 y muchos años, ser David Attenborough en la BBC y demás, hace exactamente lo mismo y mueve a millones de personas cada vez que salen sus programas para verlos, y es el objetivo. Hay que comunicar por el sistema que sea, y la imagen muchas veces mueve más, bueno, la imagen mueve más que las palabras escritas, pero es la forma de intentar llegar a la gente, venderles ese producto, que es lo que queréis.
Yeah, certainly communication is key for every research project.
Dr. Miguel, what do scientists communicate in Twitter?
This is a good question. So first, we try to fight against miscommunication, okay, fake news and all that. Second thing, I mean, I think I have put my Twitter account there, or the one of my group. We communicate which articles we have published and provide the link, open source link, open access link, sorry. We communicate, we let the people know which activities we are doing. Probably tomorrow or the day after, I will publish a tweet, or someone will publish a tweet in the group saying I was here today. So people can see how our scientists work and which are the results we have. No? This is and then there are some discussions. Of course, we don't focus on that because you can enter in a world of, back and forth questions from people that do not really want to learn. But we try to do a job of dissemination, of outreach. Okay.
So are you actually entering into a kind of dialogue with other teams that are doing similar research? Is that how you maintain contact with other colleagues? Or do you try to keep it to yourself? How much competition and rivalry is actually influencing, maybe undermining research?
That's something that has always happened. We don't reveal what the big results are not revealed until they are accepted for publication, until they are not public in a journal. People know what I am doing, generally speaking. Okay, people know that we are doing high-energy radiation detectors or solar cells, designing how a photon and the matter interact, but I cannot reveal what is going to be next. First, because you can be scooped. There is a lot of competition, I mean, enormous competition, and funding depends on who is first and all that. And second, because journals don't like this. So if you publish a graph, a figure in Twitter, or you publicize it in a slide, you have to be careful because you cannot reproduce that then in the journal because there is a copyright. The journal will want to have a new one. So you need to be careful with what you disseminate. It is not entering in conflict with rights later on.
Back to the general thing, be careful what you put on social media.
No, yes, this is first because not only for science, right? Yes. And second because it is going to be always there. So what you put, you cannot erase it. It will be there and will follow you forever. Okay? And maybe there is. I wanted to make a very quick comment because just to give an example, okay, of how to communicate. In the talk, for example, of you, I remember the one of the X. I remember also the one of the other Ciudad Campo team, the diffraction. The motivation, the introduction, you use a lot of text, right? And you may be asking yourself, what is this guy wanting? Like, what does he want us to do to introduce in a more fancy way a topic? It is difficult, right? For example, in your case, you could have used like figures of the liters of, I don't know, refreshment drunk by people or population per hour or whatever, and how we are aging as a society, and then we need to preserve our teeth, these type of things, 2 graphs, and then you introduce, then you speak about, you read or you remember what you wrote in the slides, but with 2 very, let's say, punchy figures that everyone will remember, right? The guys from the diffraction, you could have started with the diffraction, or like duality of particle and waves, okay? In terms of photons, and then you say this is a very important topic. 21st, like the 20th century, has been. There was a revolution in physics because of this, the discovery of this duality. Now we are going to explore the diffraction effect, which is like one of the consequences of this duality. Instead in photons, which is very difficult, in a sound wave. And then with this, you introduce the people and catch them and tell them what I'm doing is important and it makes sense, right? It's not I'm doing this because I need the manuscript.
Yo por lo menos los alumnos de Ciudad del Campo, que estabais en segundo de la ESO en Ciudad del Campo, yo sé que en lengua y sabéis por qué lo sé lo de lengua, yo sé que Ana, mi mujer, os ponía que teníais que hacer, me parece que se llamaba introducción o algo así, el captar la atención del público y justo ya a continuación, ya mi nombre es no sé cuántos y voy a hablar de no sé cuántos, pero haces una introducción inicial para captar la atención. Entonces era sobre eso. Y sobre algo de lo de el compartir información, también una historia vieja que muchos deberíais conocer ya. Hay un señor que se llama Darwin, que a todo el mundo le suena. Hay otro señor, bueno, que se llamaba Darwin, y otro señor que se llamaba Wallace, que ya no a todo el mundo le suena. El señor Darwin hace el viaje del Beagle, da la vuelta al mundo, recoge montones de datos y empieza a escribir un libro. Y se tira 50 años escribiendo el libro, una cosa exagerada, iba a ser aquello una enciclopedia bestial. Y empieza a recibir cartas de otro señor llamado Wallace, claro, esos son mediados del siglo XIX, 1800 y pico, empieza a recibir cartas de ese, que era un jovenzuelo comparado con Darwin, que le dice, oye, es que tengo esta idea y esta teoría que a lo mejor podía ser y he recogido estos datos, y entonces Darwin se empieza a dar cuenta de que le estaba contando en las cartas la misma teoría que él quería exponer sobre la evolución y el origen de las especies. Y entonces Darwin le vio las orejas al lobo y dijo, uy, voy a publicar rápidamente, y ahí ya la única forma de publicar que había era libros, y entonces publica rápidamente para llevarse el mérito de la teoría, de ser el primero en publicarlo. En la actualidad hay mucha competición porque se les exige a los investigadores las publicaciones. Si eres un investigador, seas profesor en la universidad o lo que sea, te exigen publicar artículos. Y si no eres original en esos artículos, no te los cogen y no te los publican, y entonces puedes llegar a perder tu empleo por no publicar. Entonces hay mucha competencia, mucho no voy a contar lo que estoy haciendo por si me lo pisan. como casi le ocurre a Darwin, porque Wallace estaba avanzando ya en la teoría y tuvo que publicarlo rápidamente para llevarse el mérito. Entonces, es lamentable, pero es así la sociedad. O sea, hay que ser el primero en publicar y no hay toda la colaboración que debería haber entre científicos. Aunque luego, cuando se juntan, les gusta hablar. O sea, cuando están alrededor de... No debería hablar de pintas de cerveza ni cosas parecidas delante de la audiencia por edad, pero cuando se juntan les gusta presumir, decir lo que van haciendo, y eso siempre sirve de ideas para ir haciendo nuevos grupos de trabajo, ir mezclando información de uno y abrir nuevas líneas, y eso es lo ideal. Así es como va a avanzar la ciencia, a base de lo que se intercambia.
Andrea, I believe I wanted to comment on something.
Yes, 100%. We should two faces or two sides of the same coin. The one is, I'm sure if you look into TikTok and you can find University of Seville or Autonomous University of Madrid or Cambridge. In Instagram, 100% sure. People trying to adapt to your language or the way in which you communicate with the TikTok videos and so on. We do our best. I will never record myself doing a TikTok video because I'm shy and I don't know how to do it, but we try. What I mostly do is going to schools or this type of activities, or Feria de la Ciencia, I don't know if you, science fairs in Madrid, right? And try to engage youth to do science, and very importantly, try to engage young women, because this is something that it's always a problem in physics, for sure. It has been a problem because traditionally it's a men work, okay, and we are losing like 50% of the let's say, how to say, the hands, right, or the minds that can work in physics. Nowadays the trend is changing because there are more examples. Like Don Juan was speaking before about Margarita Salas, Spanish examples, international examples, and this is very important, and that's what we try. TikTok, complex. We have the groups TikTok in case some of you come to my group in a few years and want to record videos and in representation of the group, but I cannot do that for the moment.
Related to this topic, Gordon, I would like to ask you a question, because in every project it is essential to manage data precisely and rigorously, discriminating the validity of the information and recognizing potential biases, as Mr. Anaya was saying. Therefore, what methods can we use to avoid such biases and ensure the objectivity of our data?
Yeah, it's a very interesting question. Thanks. I'll do my best to answer it. At 72 with a shrinking hippocampus and dissolving teeth. Yes, it's, as I was trying to explain earlier, your only authority is not your professor, it's not your teacher, it's the data. So you have to be able to trust your data. And what your professor and what your teacher should be teaching you is how to look at that data and scrutinize it. One of the first things is it reliable? How do you know whether it's reliable? Well, can you repeat it? Can another laboratory repeat it? I was interested actually in the presentations of the microbial cell. And it's something I'd like to do in the school. Sounded very interesting. But there wasn't enough information in the presentation to tell me how to set up the microbial cell. I understand you have to separate the reduction from the oxidation. You have ion flow through the cell, you have the electrons flowing through the external circuit, but it wasn't clear how that was set up. So I missed an opportunity there. Then there's sampling. Again, I noticed in the memory loss, which I was very interested in, by the way, there was only one 50-year-old. I think the sample was very small. I think general conclusions were drawn from just one unique example for each case. Now that was very interesting. I would call that preliminary experimentation, but it's not rigorous enough to stand on its own. Then control of variables. In the energy drinks, again, fascinating experiment. Can you do 45 press-ups, by the way?
No.
1 minute.
I don't know.
There was some pretty astonishing data there. What were those press-ups? Were they shallow press-ups? Were they deep press-ups? Was there a kind of expectation bias there? Students were drinking the energy drink. I'm sure some of them were hoping it would increase their strength and energy. And that might have influenced that little bit of extra effort that gave that extra push-up. So I thought that was quite interesting. Also, I'm not sure whether the variables were controlled successfully enough. What is it in the energy drink that's boosting their energy and their strength? Is it the caffeine or is it the sugar? And so there should have been basic controls to separate out those elements. I'm not wanting to criticize these efforts. They were all fascinating. But I see science as a continual debate. And this is probably something that Dr. Miguel can explain as well through Twitter, this constant desire to share data, to discuss it, and to take it further. So in summary, I would say the essential thing is maintain a dialogue, accept questions, accept criticism, if you like, constantly trying to improve that data so there's something we can believe, something we can rely on, because that's all we've got.
Thank you very much. We would truly love to continue with this conversation, but unfortunately time is limited. So now we will open a round of 3 questions, and feel free to ask Dr. Miguel any curiosity of yours. Does anybody have any questions? Please don't be shy. Okay, I'll break the ice then. Dr. Miguel, artificial intelligence, as you may know, is advancing by leaps and bounds. So how do you think the implementation of this technology could affect the research you're currently working at?
We are already using artificial intelligence, I didn't explain. So one of the main research lines we have in the group is how to characterize all our materials, especially by microscopy. So we use optical microscopes, X-ray microscopes, electron microscopes, and this creates data sets of as many dimensions you can imagine, okay? You have the real space dimension, the reciprocal space dimensions, composition, structure, a lot of information in millions of pixels, okay? So for example, for us, it's very, very important to analyze those images, not by a human, analyze them by an artificial intelligence, because we are talking about terabytes of data in 1 or 2 days of sessions acquiring information. So we need something to analyze them quickly. And the way in which we use artificial intelligence is by using machine learning. Okay, so we feed or we train models that are, again, as complex as you want to predict what is going to happen in an image even before acquiring it, or what is going to happen in a device in time, even if the device is fresh. And all this is possible because of the huge amount of information that we can collect in the big facilities, grandes infraestructuras like synchrotrons in Spain or in the UK. Long story short, yes, artificial intelligence is erupting in science and breaking all the previous ways of working quite in a disruptive way. Yeah.
Throughout the roundtable, we've talked a lot about the effectiveness of communication, but what about the impact? How do you think your research project could improve our day-to-day lives, or it may worsen them? What do you think about that?
I hope some of the message was clear during my presentation. One of the things I have in mind always to design experiments, design projects, and decide which are the questions we want to answer. This is something very important. Deciding which questions we want to focus on is what is going to be the medium-term impact in society. In particular, for us, how we harvest and use energy in the best way. That's a reason because we investigate around how to make materials better for solar cells, LEDs, high energy radiation detectors, and nowadays, and this is the future, this is what I say, we don't have the publications already there that you can read, but this is what we are doing right now. We are working on quantum computing and how to use our materials for the next generation of computers, okay? But this is the sort of investigation that still we keep a little bit silent, so because we cannot reveal the results we have until they are approved by our peers and published to not lose the priority, which is very important for patents as well.
Does anybody? Yeah, thank you.
The coding. Yeah. So first, my group, one of the pillars of the group is modeling how light and matter interact. This is pure, let's say, these are models, theoretical models with equations that you cannot solve by hand. So you need to use very advanced models, softwares, and for that you need to code, okay? Second is to deal with this enormous amount of data. And actually, we use Python mainly because it's an open way of, it's an open language with thousands of forums of information that can teach you, and you can be autonomous in learning. And there is a lot of tradition in Python already in connecting it with artificial intelligence functions. So you can call from your program or your code, you can call functions that are already almost prepared, and you can tune them a little bit. And with those, we implement the artificial intelligence analysis and enhance it for our data analysis. And third, representation of the data. We don't use Excel, we don't use Origin, we use Python or MATLAB to represent the data. And this is something that I wanted to mention as well. Correct me if I am wrong, but I think only in your talk I saw error bars, okay? And this connects a little bit with reliability of the data representation, the honesty I mentioned in my last slide. You need to be honest. You are not 100% sure about something. There is uncertainty, and you need to plot your error bars. I'm sure no one here can assure me that the pH was 5.00 infinite zeros. There was an error in the estimation of the pH of your solutions. Okay, you need error bars.
I would like to follow the question with, have you ever had to do a program from scratch?
Yes.
Have you always used a model or skeleton?
Yes, I'm not the best in coding. I had to learn because, I had to learn English. I'm not an English language lover or coding lover, but this is the world in which we live. What I'm sure is that the people that I hire, they are good in coding. Okay, and And yes, we need to write codes from scratch most of the times. Nowadays, you have ChatGPT, which is very good in helping or finding errors in your codes when you write them in Python. And I don't blame a person that uses those tools to write code and all that, if they understand what the code is doing. So it's like I don't mind if you ask ChatGPT or Gemini or whatever to help you write in a section of a manuscript, if you know 100% what it is doing and you tune it to be your paragraph. Because, and here there are a lot of teachers, we catch you. We know 100% when something is not written by you. So maybe it can help you to know how to structure a text, but you cannot copy-paste. Okay, I mean, you can, but you shouldn't.
Las máquinas son tontas. Las máquinas son tontas, no te puedes fiar de una máquina. Inteligencia artificial fueron las calculadoras. Cuando estudiábamos las tablas de multiplicar y luego hacíamos operaciones por escrito, una máquina donde tecleas y te aparece el resultado. Eso era inteligencia artificial. Las calculadoras se pueden equivocar. Depende cómo teclees los signos, las operaciones, te puede dar un resultado erróneo. No debes fiarte. La inteligencia artificial, no debes fiarte. De Google, no debes fiarte. De todo hay que aprender, no sé cuánto, pero de nada te debes fiar, incluidos los profesores cuando dicen que no te fíes de nada. O sea, que hay que poner en duda todo y comprobar, corroborar una y otra vez, que es una herramienta que acelera las operaciones, lo que sea, el uso de inteligencia artificial, pero es una herramienta que alguien ha programado. No vamos a entrar en sí. Se puede programar de forma que los resultados tiendan hacia una línea que interese, y eso ya, teorías conspiranoicas todas las que queramos, pero desde luego, como máquinas que son, están para ayudar, pero no son la solución. La parte humana tiene que acabar al final vigilando lo que ha dicho la máquina o el resultado que ha salido.
Bueno, esto es importantísimo, hay que ser crítico, ¿vale? La capacidad crítica, y bueno, es lo que os han estado contando todo el rato, ¿no? Es, tenéis que aprender a aprender, pero también tenéis que saber cómo criticar lo que leéis, ¿vale? Y esto, por ejemplo, a mí me recuerda mucho, cuando yo estaba en el colegio Ciudad del Campo, hubo los atentados del 11S, una cosa muy da pena, ¿no? Pero ahí se me consolidó en mí una obsesión por la información, ¿ok? Desde ese día, yo leo todas las mañanas, antes de venir hoy lo he hecho, El País, El Mundo, el ABC. No leo solo información de una fuente. Leed de muchas fuentes y cread vuestra propia opinión. No tiene por qué ser toda de aquí o toda de allá. Lo mismo exactamente pasa en la ciencia, ¿vale? Porque lo que estaba diciendo el profesor sobre el diálogo es muy importante. Si no, no habría evolución. Si algo fuese tajantemente cierto hasta hoy, ¿qué hacemos después? Ya no hay más ciencia. De hecho, la ciencia evoluciona porque estamos negando todo el rato lo anterior, o corrigiendo o mejorando todo el rato lo anterior, ¿vale? Y de ahí viene el tema de la honestidad. No seáis muy tajantes cuando decís algo. Decís, bueno, nosotros lo que observamos es esto y cuadra con esto o lo otro, pero no tendáis al dogma de fe de esto es así. Exactamente.
So thank you very much. And with this last intervention, we close this amazing roundtable, thanking everybody that has participated as members and also posing such interesting questions. And now we finally give the floor to Mr. Iván Martínez, which is the General Director who will close this Congress. So I warmly invite him to the stage.
Thank you very much. What a big responsibility closing this scientific congress after all we've learned. I wanted to start by thanking you, students, for an extraordinary day. This congress has been a window into the future, a celebration of curiosity, teamwork, as you mentioned, and the desire to understand the world around us. Throughout the day, we've seen brilliant ideas, bold questions. We've learned a lot. At least I've learned a lot. Thank you very much. And also creative solutions. Each of your projects has reminded us that science is not just another school subject, but a way of seeing reality with fresh eyes and find applications to improve our lifestyle and our planet. I would like to continue by thanking all of the science teachers within SEK Education Group. I didn't have the tremendous luck of having Don Juan as my biology teacher. However, and there's where probably the wow in the room comes, I've had the chance to learn from Don Javier Sanz, from Rosa Suarez, from Carmen Cambón, Carmen Martinez, some of them still your teachers. So I believe just a huge thank you to all of the science teachers in the room and the other side of the screen. I'd like to close this event by mentioning something. You've been talking about many, many things, but you've underlined data, and you've underlined, to some extent, collaboration with some limitations as well, but data and collaboration. And I wanted to just mention briefly something I find inspiring, which is citizen science. And we haven't mentioned this today, and it is there as well. Thousands of people around the world are helping scientists study birds, and this is a passion I share with Don Juan, simply by observing them and recording their sightings. A fascinating example is the platform eBird, which is a global project that allows anyone from their phone to share bird observations. What began as a tool for bird watchers as a hobby has become a priceless scientific database, and there's where data comes. Scientists in the US are using this data on a daily basis to study how birds move, where they live, and how climate change is affecting them. Here in Spain as well, we're also making a difference. We have bird monitoring programs led by the Spanish Society of Ornithology, SEO. These programs have collected data for over 25 years on the evolution of bird populations in our country, and thanks to the participation of thousands of volunteers, we know now that species linked to agricultural environments or common species in our cities, such as the barn swallow that you see now already, or the house sparrow, are disappearing from our fields and cities. This information is essential for making conservation decisions and understanding how human activity is transforming our ecosystems. And the best thing about this is that you can take part too. So you can be a part of that easily with your phone. All it takes is to observe, record, and share this information from your backyard, the window of your room, a park. Science needs everyone, as you already mentioned earlier before, and you don't have to wait to start changing the world. A last thank you to our hosts today. Thank you very much, you've been amazing. Thank you for your passion, your energy, and for reminding us that the future of science is bright and in committed hands. See you all at the next Congress. Thank you very much.